pulling it down from another source or pushing it directly to another source. I mean, that would be interesting, but it's not really the web streaming aspect that I was going after.
Okay, cool.
I guess the thing is, like, we don't run the camera, like our customer's running a camera somewhere in the world, and they're streaming the video into our data center, and then.
I've done a lot of RTP-based applications, but that's not what.
Well, that's kind of what I'm looking at setting up, or what I was looking at setting up, but I kind of moved on to the projects. It was kind of just in a hobby capacity.
Well, the goal of my talk is largely like if you want to start accepting video. So I'm actually not going into live streaming too much.
Well, it doesn't necessarily need to be live, but
Yeah.
just where I'm not using all the bandwidth from my upstream location.
Yeah, exactly. This is about how to push files, well, how you need to be thinking about video, how it functions, and how you push those files into your application. And therefore, here are a bunch of challenges around video, so break up here. But I'm not doing like there's actually not a lot of Python I'm talking, so
Okay, cool.
it's like
Probably
make
not
sure
a lot.
you're thinking about these things.
Probably not a lot of iOS either if you're going to be talking about WebRTC.
I'm not doing much. I've done a different WebRTC talk. This is pure video.
Okay, cool.
Streaming, progressive, that kind of stuff.
So what does your company do? I don't think I saw a description or anything of that.
We are video management, enterprise video management. So we essentially have a video platform that does a lot of what I'm going to talk about. All of what I'm going to talk about is going to talk about a lot more. And so that's why we were at the talk the other day, and people started asking how do I add video to Django and other things, and it turned into a bit of a conversation. So I'm trying to just address that.
No video file field or anything on the
Exactly.
database?
And you're done.
A live video stream?
Yeah. Pip install video.
Cool. I'll be looking forward to using your code and not writing my own.
Make sure I'm in the right place. Web Python group?
Yep.
Okay. How come I don't recognize anybody?
None of us have laptops out. I'm Paul Owen.
Oh, I'm Tip from Code.
I'm Cole, nice meeting you. What kind of Python stuff do you do?
A little bit of web development, small projects of my own, actually.
Okay, cool. Any video stuff?
I'm sorry?
Any video stuff?
Nope. Barely HTML stuff.
It's because my talk is boring.
It made me cry.
I can't stay awake. Did you guys ever have a barbecue? Yeah, with Peter and get together? No, okay.
We should do that.
Yeah. I thought that was happening while I was
Nothing happened with us.
Yeah, everything stops. Yeah.
I haven't seen an email in a while.
Peter and Kevin were talking about it at a pub back in December, I think.
Yeah, I didn't go, so to that, so I didn't know about it.
Email group.
I might have a couple of days worth of learn. So, well, now that I'm no longer at Object Rocket, not doing the learn or the Python coding, Python code.
Right.
Jacob's third, I think. Yeah, I think.
It always sounded fancy to me, like you're sort of a black tie.
Black tie pizza.
Yeah.
A little bit.
It's kind of fun though. I like going to the Python coding thing.
I'm really bad. I never came out to that.
I don't like being labeled an expert though. No matter how much I protest. Yeah, I've been doing it for 10 years, but I'm not an expert.
So, since I'm not doing that anymore, so I'm more free time.
So So July-thon?
Yeah, July-thon coming back?
Yeah.
Maybe.
Did that my hoodie?
January-thon? Didn't we do that one?
January-thon
January-thon.
is currently
Active.
not working.
We're all losing. No, there's still some people out there committing. Like you go to the site, you still see.
Yeah, the site's live. I mean, it's still, like, people, if you added a webhook, it's still, you can see the live feed on the front page.
Yeah. I was checking out this one the other day.
Nostalgia.
I had to,
The good old days.
I hadn't updated in a long time. And the server that I was running it on, like, either crashed or, like, became inaccessible. And
Don't you know somebody that could take care of that for you? Was it at Rackspace?
it's a flat server. But, long story
Did they
short,
turn off the
Became
cloud?
accessible.
I had to bring up a new box. And it's a cloud, so you're supposed to be able to do that. But, like, I didn't have any of the code for the Nginx push stream. Right. Which you did, like, a long time
Oh
ago.
man. Oh, you were running on
So I
some
was like-
ancient version of that.
I was like, so I found a Docker image that is just streaming that. Migrated everything over to Docker. So
Nice.
now it's running in Docker on the cloud server.
Oh, you're not running in Karina or whatever?
I think
Was
we
it shut down?
deprecated that.
Yeah, yeah.
Shut that down.
Okay. I think I had something running.
Probably not running.
Yeah.
I guess. Yeah, that stuff got defunded once we started moving to FAWS and managed GCP and Azure. So like, if people come with like, hey, I got this app from Docker, and then they point it at like the 5 or 6 different things you can just use. And we actually get a pretty good deal. We get since we can like buy a bunch of Amazon, we can get a discount and then still give you a discount if you buy through Rackspace. Then we get a cut of that. So it's actually cheaper for us to move you from cloud servers to
So
Amazon.
you just should have redirected the cloud server APIs
You should.
to coordinate AWS between. No, we would have known, we would have said anything.
Because the margins are so low. Like you have the electricity, like the whole building, keeping the data center alive, networking, all that stuff. So much more money than just having Amazon giving you it at a super discount. They're losing money like crazy.
That's what they wanted to do. Right?
Yeah. So they're giving us money. Let's turn off our cloud.
I think I see this business strategy. If we pay our competitors to shut down.
Increase price.
Exactly, right?
Yeah, but they're all doing it, but Microsoft, Google,
Yeah.
Amazon, they're all just losing money like crazy.
Gotta change it, that's great.
No, maybe.
Unless they're using it as a loss leader for services or something.
I know they charge a lot more about networking. So Rackspace has been really generous about networking traffic. You can get a lot more networking through Rackspace than you can at Amazon. You get nickel and dime at Amazon, but Rackspace is pretty generous.
Like, where's the coming from, the traffic inside? Is there clusters or outbound for
Well,
inbound traffic?
inbound traffic you get is free
Okay.
at Rackspace.
Okay, but not in AWS?
Outbound. Well,
I thought it's free internal.
It's a little bit, but you also get charged for API calls, and like everything that you do is charged at Amazon. Then all the bandwidth is more expensive, unless you're like super volume, then you can get a discount. Anyway.
7:05, so I figure we can start. Welcome everybody. We haven't met since October, so this is the first of our 10 meetings this year. Nice to have everybody. Couple quick announcements. PyCon registration is currently open. That's like May 9th through 11th will be the talks. It always sells out, so if you want to go, sign up soon. It's like $400 for individuals, which is not too bad. I think that's really it. Oh, we are looking for ideas for venues for PyTexas this year, because it's been 2 months since PyTexas 2017, and we're starting to ramp up the process. We're going to try to not do it the weekend before Thanksgiving in 2018. So probably a little earlier in the year. So if anybody has any ideas on venues, or if you were there and hated, galvanized, or loved it, I'd love to hear more. And if you're thinking about doing a talk at PyTexas, think about coming to me and telling me you would like to do a talk here, and you can practice your talk and then sort of ramp up to that. So, yeah.
So, PyTexas is in Austin now, not College Station?
So last year was the first year that we did it in Austin, actually since 2008 or something. I went through the history back in November, but like I think 2008 was the only other time it had been here. What we're probably doing is switching to a 2-year cycle, sort of like the PyCon model. So we'll do Austin this year as well, and then Houston or Dallas are probably big candidates for next one. Or San Antonio, actually. I'm really kind of pushing for San Antonio because we've never done one in San Antonio, and a lot of South Texas attendees could be more accessible. So anyway, if you think you might want to give a talk there, that's good prep for doing a talk in like 2019's PyCon. So anyway, I would love to hear from you. We're also always looking for sponsors for Ffmpeg because it's not very expensive. You get to pitch your company in front of an illustrious group of people. Anyway, so this talk came out of a discussion back in August. We were talking about Django, and somebody was asking about video. And I forget who it was at this point. But Josh here has done video for a little while. And ended up half giving a talk in the Q&A there. So we decided to make him legit. So we've been talking about doing this for a couple months, and I'm really looking forward to it. So without further ado,
Hopefully not too boring.
that's
not where I'll leave.
In that sort of frame of mind, I'm going to be talking through video, but it's going to be at a fairly high level. So we can go into any details if you guys want to. We're a small group, so just interrupt me, whatever. If it starts to get boring and you want to jump forward, I've got a lot of material here, so we can move around. All right, so like I said, I'm Josh Marshall. I work at Studio. It's a company that I co-founded that we build a video platform that handles a bunch of stuff, live streaming and video processing and management, and ties into a bunch of different enterprise applications, pushing video into Salesforce and a whole bunch of different areas. And so what I'm talking about tonight is just a part of that overall process, but that's where my experience comes from, and I've been working in video for a really very long time. So why give this talk? Obviously, this is my personal bias, but I believe video is a fantastically powerful medium. I actually think it's, right now, of everything we have, it's the most efficient communication medium. That's part of the reason that it's so big and there's so much data in it, but it ties in directly with how we understand the world, our visual system, our auditory system. Anyway, so it comes at a high cost of complexity, and that means it can be challenging for us to incorporate it into applications. And on the web, there's just, as you'll see, there's even more reasons why that can be complex and hard to deal with. And as per the August meetup, you guys, it's just an ongoing thing. Our customers come to us all the time. We have people come in like contact and things that I've been suddenly asked to add video to my application, and I don't know where to start. So hopefully this is a way to start thinking. Buyer beware. This isn't a sales pitch for Studio, but I do work at a startup. I've worked at a company that does this for a few years, so there's a reason why we built things we did. So I'll reference that probably later in the thing. I'm going to dive into video tech. So I'm not going to go deep, like I said, but I'm going to give, just from a personal perspective, I personally like to understand as much as I can of the fundamentals, even if I'm not directly accessing those. It helps me debug my software, helps me understand why systems behave the way they do. So I'm going to go through video technology and a bit of a history. I will definitely be talking about some of the web history. Why does video function the way it does on the web today, as well as some of the things looking forward. But I'm not using a lot of Python. Now, we build everything at UStudio, all of our backends and things like that on Python. So I'm happy to answer any questions on, well, how have you guys done this, anything that I can't answer. How have you guys done this in Python? How have you solved a particular challenge I raised? Think about, but I'm not putting a lot of Python code up in front of you guys. So hopefully that makes sense. All right, so you've got you want to accept video in your project, and maybe it happened a little bit like this. You've got a little web app that's running for your company, for your own thing, for clients, whatever it is. Maybe it's in Django or Flask or some web framework. Maybe it's something that you've hand-rolled over many, many years, and the only reason it's up and running is because of these like crazy deadlines and your long hours, and you can't ever get to any of your product backlog. I'm sure not like that for any of you guys, right? And then your boss walks in, right, and they tell you a story, right? Like, my kids were using X app the other day, or I was using Instagram the other day, or something like that, right? And video seems pretty cool. Can we just allow our customers to upload video directly to us, right? We already have other files in our system, right? We have JPEGs and PDFs, so it's conceptually the same thing, right? It's just another file. And I don't want anything too big, just make it work like YouTube, right? We all have those things, right? It's sort of I say just sprinkle a little like social on my app, or a little mobile on my app, or a little cloud on my app, right? Like it's just, I'll add it after the fact. So video fits into that same model in that you have to design your software around it. You have to update your software to take advantage of it. You can't, it's not a tip install video sort of thing. So as I'm talking through, I'm going to go through three main areas. It's kind of interleave themselves, but what is video? And I'm mostly focusing on digital video. There's a long, rich history of film and motion pictures and television that I'm not going to get into. But what is digital video? How does it function on the web? Or another way of looking at it is how do browsers deal with video? And how do I design a software to use it? So this is going to be pretty basic. But a video, for the purposes of this conversation, a video is a series of frames. For those of you who don't know this, a little fun history, that's Edward Muybridge. It's one of the first examples of motion pictures. He was working with a guy who had a bet that horses in their gallop never had all their feet off the ground. And so Muybridge was a photographer. The guy paid Muybridge to go prove it. While building a system that captured a series of frames, he ended up murdering a guy who he thought fathered his child with his wife. Didn't actually occur, but he got off because it was justifiable homicide. He claimed, there's a fun little connection here. He claimed that the reason he murdered him was because of an injury that had occurred in Central Texas when he got slammed into by a stagecoach. So a little bit of Central Texas history with this picture. Anyway, so early motion pictures, series of frames, right? So yes, a GIF is technically by this definition a video. A frame, again, for a digital video conversation, it's a series of pixels. And for today, we're going to largely focus on, there's obviously you can have black and white video and other things, but we're going to talk about pixel as composed of RGB values. And usually, but not always, a pixel is represented as square in video. There's a lot of different mechanisms, anamorphic aspects and other compression formats that will actually stretch and squeeze the pixel to get more data out of it or less data out of it as they desire, but pixels are usually square.
Does that hold true in the hardware realm, or could they vary there too?
Well, when you're talking about like the actual imager, so photo sites can be any number of shapes, right? And so they're circular. So like but the representation once it's captured is usually at least digital. It's pixel, it's usually a square. And usually what's coming off the imager would start, no, that's not true. There's a whole other conversation we talked about, like CCD and CMOS imagers and different functions. But yeah.
I should assume it's a square in hardware too.
It's not an unreasonable assumption that what's coming in is represented by a square. So actually on this is a Bayer imager over here. So in your phone or on like the Red camera or really any single imager system, which is a lot of like your SLRs and all that stuff, what you have is you have a series of photo sites, and then in front of each one is a filter that accepts a certain color. Now you notice there's more green in the Bayer image than there are in the blue. That's because we sense more detail in green, and so it's, there's some reasons behind that. Our eyes detect more detail in green, and our eyes naturally detect more detail in black and white or luma values than they do in color and chroma values. So anyway, if we look at video as a series of frames, which each are a series of pixels, each have 3 channels, and it's not actually RGB, but I'll get into this later. But for right now, there's three channels of color, and let's say standard HD video, 1920 by 1080, right? And we're at an NTSC-ish frame rate, so we'll do 30 frames per second. Just the raw value there, and by the way, 8 bits per pixel value is not actually that great. HDR and other things bumps it up to 10 and 12 bits and all that kind of stuff. But most video formats that I'm going to be talking through today are large, and most applications of them are 8-bit for some of these values. So anyway, 1.5 gigabits per second, you're not exactly going to be streaming that. Yeah.
You put channel per color or 8 or
Well, in this model, I'm saying per pixel value. I'm going to get into the compression, which
Okay.
changes some of that. But for this conceptual model here, the red channel for that pixel, the blue channel for that pixel, the Bayer image actually confuses it a little bit, because usually when you're doing this, you have like one of these, you have many more photosites. This isn't 1920 by 1080, and we're throwing away the red, like you're actually dividing your resolution by third. You have way more pixels. You might have 3x the number of pixels necessary. Anyway. So, that doesn't include audio. Audio is a series of samples, and it follows, it's just a much more simple model there. For those of you, imagine everybody in here is familiar with sampling rates and how to sample signals. So let's say this is your standard CD setup, right? You've got 16 bits per value. You've got 2 channels, so that means 2 streams of these values for stereo, and then you've got 44.1 kilohertz for how frequently we're sampling this, and you get 1.4 megabits per second. Still very small, but even that is larger than in some cases the video you want to send, just the raw audio. So great. We need to compress it because if we're talking about mobile, I just have some of the numbers up here. Your average mobile 3G, 4G is just a few megabits per second is what they're experiencing on that side. So we have to shrink this video incredibly, right?
Can you give an example of how bad, how big, how much you shrink it?
Yeah, I'll get down to, well, I mean, just off the top, if we're doing a 1920 by 1080, I think the example in here, I have a 3 megabit per second. So you're going from 1.5 gigabit per second down to 3 megabit per second, right? So 500x or below, right? Like inverted, but anyway, a lot. So we've been doing it for decades. So these are a lot, like some of these formats you may recognize. Wait, which one's good riddance?
Real video.
Oh, real video? I have a soft spot. I'm talking about real video in a minute. But yeah, old, in some cases, some of them are still used today. And it's just a selection, like the Intel Indio, I think that was like 92, and there were actually formats before that too. But we've been trying to compress video for a long time. And so there's a standard process, no matter what compression formats or whatever we're going to talk about, you can generally break the problem down into a couple of different areas. How do we store these video files, right? And you have container formats, video formats, and audio formats, and they are separate, although in some cases the specifications might be published together in multiple parts. I'll get into that, but another way to think about it in your head is if you download an MP4 file, right, there's a video track in there, there's an audio track in there, there may be metadata tracks, and I'm not going to talk too much about metadata tracks today, things like subtitles and timing information and a bunch of different other assets can be in there. And they're stored, they're multiplexed inside of one file. And the way they're done the way that is done is via container format specifications and the video codec and audio codecs and a number of things. So here's a little less conceptual model. This is the ISO-based media format, which is actually the foundation of Ffmpeg 4 files. So if you are downloading an Ffmpeg 4 file, it is built on top of the ISO-based media format. There's a lot of things in there that I imagine you don't recognize if you have never torn into one of these files. This is not talking about any of the video compression or audio compression. This is just a container, right? It's just how do we structure any number of video codecs or audio codecs or metadata tracks, that kind of stuff, inside one of these files.
So this is what you get off a DVD when you take off the CSS protection? This is the
not DVD. DVD is VOB, and it's Ffmpeg 2 and a bunch of other things. I'm not digging into what constitutes a DVD.
But this is the disk format that came before that. I forgot what it's called.
No, this is ISO. This particular instance is the Ffmpeg 4 part 10, part 10, part 12, part 10. I think. And it's just a fundamental thing that's used for actually the Ffmpeg 4 container format, and I think JPEG 2000 used it, and several other ones. So it's actually been used in some new image formats and other things. It's just a mechanism for storing that. It's not used in Blu-rays or DVDs. I'm trying to think. I don't think there's any medium, off the top of my head anyway, that stores Ffmpeg 4 other than some like a professional recording.
I remember dealing with it back in the day, like 800 meg videos and stuff like that. I'm pretty sure that was a ISO file.
Well, there's like a CD, you know, the CD file format
Yeah,
is
yeah.
ISO 9660, but that's
It's something I can
because
put in my
ISO
DVD
is the
player.
standards body.
Are you talking about a video CD?
Yeah.
Video CD is actually Ffmpeg 1.
Okay.
So that's 1/4 of this. No, this is Ffmpeg 4. I'm not really going to talk about video CDs, but yeah, it's the same. Like the Ffmpeg standards are evolutions on top of each other, so there's going to be a lot of similarities in them. But anyway, this is just an example of a container format that would have a lot of that data inside of it. So a video. These are some long-winded explanations here, but a video codec is responsible for organizing and often compressing. Everything we're talking about here is compressing, but some video codecs are just about structuring it. The frame and pixel data, like we talked about, of a video stream into a standardized bit stream, separate from the container format. That's just the codec is organizing it into a bit stream in order to effectively read the content, because the idea is that not only do we want to play this efficiently on other devices, but we might need to seek through the thing efficiently or extract parts from it. So we have to structure it in a way that makes sense. An audio codec is very similar. It's responsible for organizing and often compressing the channel and sample data that we talked about before of an audio stream into a standardized bit stream in order to effectively read the audio content. And then finally, a container format is responsible for organizing and often multiplexing. It's not going to be doing compression, but it is going to be mixed. Is everybody familiar with the term multiplexing?
Explain.
So multiplexing, just think about it as a fancy word of interleaving the content, right? Because if you just took the raw bit streams, right, and so video is, let's say it's 10x the size of audio, so you have, you know, a giant chunk of video in front, and then you drop your entirety of your audio. If it's trying to play the audio in time with your video, then it's seeking across a massive chunk of video, whereas multiplexing is just taking the, you know, and there's a variety of different ways it's done, but you take that bit stream and turn it into sort of packets inside of the file, and then you can play them along the way. So that's multiplexing. Also, it's called plexing when we're being cool. I'm going to shorten the word. The individual bit streams of content are multiplexed in order to effectively, again, read the stream. So a container format, now, if you're seeking into a file, it's like we were talking about, it just allows you to easily jump into this point, and now you're playing the audio and the video, plus any other timing and information like subtitles and other things. So that's container format. 3 big pieces: container format, video codec, and audio codec. That's what I'm talking about today. There are dozens of container formats. There's actually a lot more than this, but I'm just saying of ones that you are likely to encounter in some version of the real world. There are hundreds, again, of popular-ish video codecs and hundreds of audio codecs. And so, because you can mix and match these across different container formats and things like that, that's a lot of combinations, which when you start talking about how does your application handle accepting video, you kind of need to understand this, because even if the majority of things are being delivered in a subset of them, like I'm talking about a little bit, you will inevitably get somebody who's uploading some 3GPP video that they shot on some ancient cell phone that's got all different video codec and audio codec than your system is expecting, and if you don't know how to handle it correctly, it blows up a little bit. So, audio, video, and container formats are designed to solve specific problems inside the video space, or the media space. And so here's just a few of them. So the recording right off a camera, like we were talking about before, especially when you're talking about high quality environments, cinematic environments, etc., you need a very, very different set of codecs and container formats than what you're going to be streaming over the web. We're going to be focusing on distribution and streaming, but you may get, if you open up file upload to your customers or users, you may get files that were exported directly from the camera. They might be Mpeg 2 files. They might be Apple ProRes files from a post-production environment. They might be any number of things. So you kind of get into that realm just by accepting file upload, a video file upload. There are some standardized general purpose formats, and we're going to be focusing on a couple of them tonight that they've really sort of taken over the web too. I'm going to burn through this pretty quickly, but how these standards are made are there's a couple of groups, at least in the main standards. There's the Mpeg group, and there's the VSEG group. And they're two different organizations, but they work together, at least recently, on different aspects of these different specifications. And so, yeah, that is, I will say that the two of them working together, they've pushed a lot of the things that you've heard, but that is changing rapidly with sort of the shift in power between who's providing video, right? It used to be, you know, traditional film, television, whatever groups, and now more and more it's folks like Google and Apple and all that who own the content, Amazon, Netflix, who own the content and therefore get to push their weight around in the means of distribution. They also have the browsers and devices and all that stuff. So there's some shifting happening. Yeah, we talked a little bit about this. Ffmpeg 1 is MP3, it was part of that specification, as well as video codecs, it's VCDs. Ffmpeg 2 is cable boxes and other things, some early network aware, fault tolerant applications of Ffmpeg 2, and then Ffmpeg 4 is largely for streaming. I say everything, it's not everything, but it's used a lot. Ffmpeg 4 is very popular.
Is that what we use for digital TV too? Like the wireless stuff?
Depending on the application, yes. Some things still use Ffmpeg 2, but most applications are using some variation on Ffmpeg 4 that I'm aware of off the top of my head, yeah. Each one of these specifications comes with a lot of parts, like I was talking about before. There's audio, there's video, there's a container format, there's metadata, blah, 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 blah. And so if you really want to, you can get into those things. The most important thing is, because we have these two groups that are making these things, and because the Ffmpeg has multiple parts, there's like 2 and 3 different names you can get for the same specification, right? H.264 is Ffmpeg 4 Part 10, and is also known as ABC. H.264 is the ITUT, or the VSEG name. ABC is the alias in the Ffmpeg 2 specification, but it's actually Ffmpeg 4 Part 10. So that's not at all confusing, right?
Plus the encoder.
The encoder?
X264.
Oh, well, yeah, there's a whole bunch of things that follow the specification, right? So anyway, that's Ffmpeg, sort of how that works. There's a bunch of other formats out there, open source, not non-patent encumbered. A main thing about that Ffmpeg group is that a lot of those are, the groups that form that, they often have a lot of patents in those formats, and that means if you're going to use them in different applications, you need to be aware of what your patent liabilities are. And that's why there's been sort of a recent upswing of things like VP8, VP9 by Google, Octheora by Ziff, Matroska, container format, a bunch of different things are taking off a little bit, and I'll talk about AV1, which is, I'll barely reference AV1 later, that's a fun one too.
Can you, without regressing too much, can you touch upon the patents? What do they protect exactly? Like, you have to pay royalties, or?
I'm not really able to do that succinctly, just being self-aware, just because there's so much history there. Like, there's patents in the container formats.
One example, just what you should be aware of and not to do.
So, actually I have some slides later. So assuming I'm moving through it, I actually have a good use case, I think, that's better than me trying to come up with another one.
I have a quick question before you move on. So are some of these codecs audio codecs and not video codecs, like OGG?
OGG is container, Vorbis is audio, Theora.
Okay, cool.
Yeah. But yeah, they all have different mechanisms. And sometimes the same group is publishing all 3 specifications, and sometimes, like Matroska, I don't think it has any video or audio off the top of my head as far as their work internally, but Matroska is a container format if you've used MKV. But if you've used WebM on the web, you actually used MKV because WebM is a subset of MKV. So anyway, that's, we can get into that. But so how does video compression work? We've talked a lot about how these files are structured, right? But how do we go from 1.5 gigabit per second video to 3 megabit per second? That's 1080p video. You have the individual implementations of these codecs can vary wide. I mean, you can go write your own video codec tomorrow, right? Like, just how do I take these raw string of values and turn them into something that then I can turn back and reproduce the visual image. But over the years, especially with the Ffmpeg standards, there's some basic approaches. So I think I'm going to talk through 4 phases here. First thing, remember what I was telling you before, RGB is not really a thing. That's because the way your eyes work, you sense more detail in black and white than you do in color values, right? Chrominance values. And so the first thing that's done in nearly any system is that you take those RGB values and you perform a little math on it, and you turn it into 3 channels. 1, which represents the luma value, that's the Y channel, chrominance of red and chrominance of blue. The reason you do that is now we can subsample, called chroma subsampling. We can subsample these because you won't notice as much. So if we have half the resolution in both of these, right, we cut down tremendously on it, and that's without doing any clever compression yet. We're just throwing away data and stretching the pixels underneath later, right? So that's number one. Most everybody does that. So now we have our reduced, and I'll talk about how some of that's communicated later, but we now have a reduced chroma channels and our high quality Luma channel coming through, and then we compress spatially. Now I'm showing you JPEG. Motion JPEG is actually a video codec from way back, but you can, there's some basic principles along the way. We have similar detail here, so we throw away as much as we can. This is often done, there's a variety of different steps, and each codec has its own flavor and exactly all the different knobs and levers that they provide. But essentially, most of them come down to some sort of discrete cosine transform at the core. You're just like JPEG, kind of. You're storing coefficients, and that helps you throw away tons of information based on standard patterns and DCT functions and things. So if you want to look into that, there's a lot of cool stuff, but that applies to a lot of different codecs.
What does that 50% represent?
I mean,
the file
I-
size is 50% of the original size.
This is the slider in JPEG, where you're saying, oh, I want to throw away 50 and 80. And honestly, I can't. JPEG I'm less familiar with, actually, than some of the other video codecs. But essentially, it's like how much are we compressing this thing, how much are we throwing away along the way. So anyway, but mainly look at the background. You can see, you start seeing macro blocks and start seeing patterns in there from as you're throwing away data. But we get to retain a lot of the area where there's detail. That's the idea, right? So compress spatially. This is also known as intraframe compression, right? So we're doing all of our compression inside one frame. And that's great. We can massively reduce the size of each one of those frames. But we still have 30 frames per second coming at you. And in reality, like if this was a video, right, and these are 3 frames of a video, there is a tremendous amount of the same information temporally, right, across time, across those frames. So we also need to compress temporally, and that's where you get a lot of the major wins. Because if we can turn it into a system, what you're seeing here is these red frames, they're called iframes in most codecs, and it's the full frame, it's a key frame, right? So we're storing just the spatially compressed version, but the entirety. So you can think about like a JPEG file shoved in there. And then we have B frames and P frames. B means bidirectional, and P means predictive. So all that means is it's looking at different frames around it, going between the key frames, and just storing essentially a compressed version of the diff, right? What changed between these frames. And we can get into details on the difference between bidirectional versus predictive and how that impacts devices and blah, blah, blah. But essentially, what you need to walk away from is understanding that some codecs don't do temporal compression, especially when you're talking about the high quality. But most of the time we're talking about streaming video on the web, and most consumer recording devices, your phone, all that kind of stuff, you're using temporal compression to get a tremendous win in throwing away all that intermediary data. Does that make sense?
Well, I'm kind of surprised that some people aren't using this, because this seems like a win that you could kind of revert from if you didn't want losing information.
Well, you definitely lose information. You're throwing away a lot of information here because of the way you're regenerating image. Yeah.
Does the type of compression, like if you don't use predictive, is it like a parameter within Ffmpeg or something, some other compression, or does the compression decide, like some compression just cannot do those predictive and
Some are designed not to do that. Some are designed purely as interframe codecs.
For example?
So Apple ProRes, I've referenced it before, but this comes with their, although they always change specifications, they might have added an interframe mode, but it's primarily an interframe only codec. And that's because it's a post-production finishing format. So you don't want to throw away any information between these, because I'm color correcting, or I'm doing a green screen, and I need all of that information. So it stores more information in the chroma channels, like I was talking about before. It doesn't throw away any information in between frames, right? It doesn't simplify it in a way that your eye doesn't really notice, because it's a lot of the same information. But when you start trying to do a matte, a green screen on a file that's throwing away tons of information here, it looks rough. So that's Apple ProRes. Now, most of the, I say most, that's probably not right, but a lot of the Ffmpeg formats actually allow you to tune that. H.264 is actually incredibly it's got a ton of different knobs and levers. So you can say, I want interframe only, and I want minimal or no chroma subsampling. You can go all the way to the high end of it, or you can go down to, you know, a group of pictures, meaning how far between these iframes of 1,000 frames, right? And so if you're only storing one every 1,000, then everything else is getting sort of generated background.
So the frames in between the keyframes here, are they generated or are they sort of derived from the existing frames?
Yeah, so that's the bidirectional versus predictive and the iframe relationship there is, so first thing we did, we simplified down to YCRCB. Next thing we did is we compressed the spatial. Now that we have those, now we're looking at, and the order can be a little different, but now we take one frame. Now for the next 30, let's say our group picture is one keyframe every second, right? For the next 30, the next one I'm going to do is it's going to be looking back at the previous keyframe, right? And then looking, in some cases, forward, right?
If it's bidirectional.
Yeah, if it's bidirectional and other things. And bidirectional can be referenced. So you see like, wait a minute. So predictive is not bidirectional, it's only single direction. Bidirectional is able to be used in both directions. And you can turn some of those off so it only is forward looking, which optimizes your device playback. So when we get later on, we'll talk about profiles for specific devices. When the iPhone first came out, B-frames were not supported because in the profile that they were using for H.264 because the device couldn't handle it, right? Couldn't keep up with it. So that's why they really matter. But unless you're digging into the details of it, you're going to largely use profiles that sort of inform device support, and then you're going to be setting higher level levers. But if you want to get into the details, there's a number. I can actually send you a couple papers that dive into it because it's pretty slick stuff, I think.
So it looks at that frame, and then I guess my question is, does it pull that frame out and replace it with something that?
Yeah, it's a simple. Think about it like essentially a diff.
Okay.
Right now, it's optimized, it's encoded. There's a couple of different aspects to it, and the way it looks at it is not a pure diff, right? Because it's throwing information away. It's like, close enough, depending on your bitrate thresholds and your amount of time you're letting it sit there and think about it, right? But yeah, it's just throwing the diff. So.
How does predictive increase the play rate? Like, you have to wait for the next thing to happen, no?
So for every one of these frames, like these frames are much easier for your device to display than these because it has to reconstitute it.
Yeah.
So the longer this goes and the longer your number of reference frames that a single frame can have, the more you have to have in memory, and if you have a hardware, right, it overlays.
Well, like if it's a bidirectional, when you're playing the device, like on the device, you're playing the video back, you have to like read ahead and look at what you've already looked at to figure out how to draw the frame. But if it's single directional, you only have to look at what you've seen before. You don't have to look ahead, so it doesn't take as much memory.
You have to store less memory.
It's less memory, yeah, and throw things away a little
So
faster.
you prefer to be single directional, and the bidirectional is better because it's more compression? Or?
Yeah.
Thank you.
And the other thing is, like on a phone, the ARM chip is not decoding this. There's like an ASIC on the chip that's decoding this. So they can't like push an update and add B-frame support.
Yeah.
It's just not there.
Hardware support is a big factor in video, just because the amount of battery they would use if you're doing all of this in software on top of your OS and all that kind of stuff is, so that's why it takes a while for these video codecs to make their way out, and that's why in many cases we're stuck with things, because there's a whole generation of hardware out there that is never going to get upgraded to use it. So that's why we make that trade-off. So if you use H.264 baseline profile, which doesn't allow bidirectional frames, then okay, you're going to be able to target those baseline devices, but it's going to be lower quality or higher bit rate or whatever. Does that make sense? Okay. So that's known as interframe compression, right? And then you do encoding at the end with the values that you're storing, just get a little bit more. That's the lossless phase, right? You're going to be able to derive that right back. And then you wrap it all up in some sort of stream standard. That's video and audio coding. A lot of this we've already talked through, but this is the H.264 profile dashboard. So a lot of these things are H.264 only codec options. That's how much variation you can have in them. So I'm not going to go through all this, don't worry. Now we talked a little bit about chroma formats, right? That's the luminance to the chroma values. And this isn't the YCRCB. It's actually just tells you how much they're throwing away chroma in relationship to the luminance value. But most things you can tell at 420, which means you're essentially your 1/4 of the chroma value is getting stored. Anyway,
So 444, it's all getting stored?
yeah, 444 is that's like when you say 444, that means professional. There's like codecs that are named 444, just to let everybody know this is a professional format, recording format that's going to retain this much of your data.
I've never heard of that, I just see it in your column.
Yeah,
What
444.
does it say, HI 444 PP?
So this is high. These are profile names. So
Okay.
constrained baseline, baseline profile, like I was talking about before. So the early iPhones were constrained baseline or baseline. The main ones that we're going to talk about,
Was
or
this
just,
kind
you know, is baseline, main, and high. Outside of that, we have high, and I believe that supports 10 bits per second. That would be much more. 10 bits per sample, right? Like we were talking about before. And so that's HDR. Now we're talking about you have a greater range of values that any individual, your lumen values or your chrominance values can have, and therefore you can express those things. Like you have less of the banding and artifacts, and you have deeper blacks and richer whites and all those kind of things. That's the HDR sets they're trying to sell you now. That's part of it. So anyway, there's a lot of different things in here, different entropy coding mechanisms, different size of your macro blocks, and how you're deriving your DCT coefficients and blah, 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 blah. So lots of stuff. That's the walkaway, right? Like I'm not diving into too much detail here. It's just the general process of compression, or way to think about it is we optimize the values, we spatially compress, often we temporally compress for interframe compression, and then we encode it into a bit stream. And then we do the whole reverse process when we're actually playing it back. So, hopefully a couple of these points are pretty clear. Video is large. Even when we throw away all this stuff, it's still very large. It's complex in all different parts, and that complex in what it takes for a machine to decode and encode it. And it's evolving, meaning these specifications, yeah, they're sort of slow to make their way across all devices, but they are continuously being rolled out. And I talk about some of the dates later of some of the codecs that came out. It's like, wait, that was 2011, that was 2013, that's a long time ago. But in video world, that's actually not. When you're talking about hardware, it has to get rolled out, and device support and all that stuff. So, anyway. Now we're going to talk a little bit about your application. So if you understand these aspects of video, then you're automatically going to start thinking about, okay, well, I'll have to redesign my application a little bit to handle these things. You're going to need to address much larger files. If you've been uploading files, especially like JPEGs and PDFs and all that kind of stuff, sometimes you can get away with some things that aren't necessarily the best thing for your scalable system. You can shove it on the machine and move it off later, right? You don't have your own dedicated upload infrastructure. Your disk space, right? You're not really that concerned unless you're overwhelmed, and largely your scalability might handle that. But with video, if one person can upload a 5 or 10 or 40 gig file, right, that might change how you're deploying your application. So videos balloon all the time, and just by accepting them, a 30-second file might be not 100 gigs, but it might be 50 gigs in a super, like a 4K, whatever, high quality format, or it might be 3 megs, a 30-second file, right? It's the same thing. You just can't necessarily control that. You can make guesses based on what average is out there, but anyway. So how do you accept these files? You've got the good old multi-part form data in a form, but it's got some issues. If you haven't pushed lots, like gigs of files over a multi-part post in the past, it is error prone. It fails all the time. You know, people shut their laptops or whatever. Like it's a long process, and so you need to be thinking about that. If you can, support breaking those files up. There are browser specifications that allow you to read in a data stream off the disk and chunk it up and then make multiple posts and other things. If nothing else, try to figure out a way that you can do some mechanism of retries, at least when they fail, because that can get fun. Any questions there? Okay. That's a fairly straightforward one, but like once you realize the size of it, maybe your upload infrastructure is going to change. So storage, right? Same deal. Your disks, if you can, cloud storage is nice. Direct upload to cloud storage is even nicer, but these are your friends, but sometimes your friends are lazy. So your cloud providers often don't provide things that you have to have for large file uploads, like progress bars. If you're not showing your users how far they are into a 5 gig upload when they're on crappy corporate Wi-Fi or whatever, they're gonna walk away, they're gonna shut their laptop, they're not gonna know it's still running, all those things. So you need to be providing that, and a lot of times the cloud providers don't provide a callback mechanism for you to put inside of your code. And so in some cases that means now you're putting a layer in front of the cloud provider to accept the upload, to provide the right feedback, and stream it into the cloud provider, right? And that just has protection too. In the same vein as progress bars, sometimes they don't tell you when the upload was successful or failed or not, so you have to track that independently. So, things to think about, cloud storage. If you're running your own infrastructure, then you can do some fun things like accepting range requests for partial upload and that retries of different parts, especially if you're using the browser site, splitting the file up. WebSockets, again, that's you're running your own infrastructure. You're not going to get a WebSocket connection from AWS that I'm aware of, but you know, then you can be streaming in chunks in a fundamentally different way, right? You can actually be storing and inspecting and doing all sorts of fun stuff with it. And then there's WebRTC. You could spin up WebRTC as accepting it in your cloud service, but this is more if your application is not about accepting video files into your cloud service or whatever, but instead it's about sharing it between folks, then WebRTC provides some nice peer-to-peer tools for moving data around, but also just direct capture. And so now you can record directly with the camera. So, like I was saying before, you need to know what you can accept. This ties in a little bit to when you start processing the video file, but you need to know what your system is prepared to handle in file size and complexity and the formats that you want to support. There's patent liabilities, like I was talking about before, depending on what you're supporting, all that stuff. And like there's any number of format or codec requirements, so just be aware you can't just look at an extension and know it's in the file. Hopefully we all know that now. We've been burned by that enough, somebody uploading an executable with a .jpeg or whatever on it. But with video, even more so, even when they're being honest, even when you get the right MIME type, it doesn't tell you what's inside of it until you actually inspect it. So, now we have a file on our system. We've stored it correctly. We've blocked any of the files that we don't want. Great. So we should theoretically be able to stream that thing, right? Because it's in the cloud. Well, now we're going to talk a little bit about browsers and how they've evolved in streaming content and why it isn't always so straightforward just to drop a file stream. So here's your real player, right? In the late 90s, early 2000s, if you remember like going to Apple trailers or any of the old sites, you had to pick the plugin that your machine, like I'm on a Windows box, show me the Windows Media format or the real player format. So we had to, when we were putting videos up online, we had to encode 3 different variations of them and then make a UI for you to go pick all those things. Kind of sucked, right? But fine, we managed it. And then Flash is actually the thing that came and saved video in a lot of cases from all that complexity, because Flash was a standard plugin that everybody had that had video capabilities, and when they rolled out video capabilities, it rolled it out to everybody who had Flash. So it added progressive support. I'm talking about what progressive streaming is what I'm talking about here. I'll get to what that is in a minute, but in 2003 they added it, and then in 2005 they added a better video codec, the VP6 video codec. So already in 2005, not a big surprise that YouTube and some of those things started coming out around this time, right? They standardized on playback, they standardized on some video codecs that they were providing, and it went pretty well. And then in 2007 they added H.264, which has still been like the darling of the video standard world, because it is so efficient and provides such great quality and all that kind of stuff. So when they added that, then everybody sort of standardized on H.264. Great, we have a playback environment that we can build custom players in, that we can put content protection and access control and all these nice things inside of, and we have a standard format. We only have to compress this thing to one standard format, which saves us. So a whole ecosystem of ad networks, etc. And then iPhone and iPad, there's, if you guys don't remember this Thoughts on Flash article that Steve Jobs wrote in 2010, it was already a response to like the iPhone still didn't have Flash on it. Android devices had it, still didn't. And essentially he called out Flash for being buggy, being insecure, and having all sorts of issues with it. Oh yeah, then Steve Jobs just wrote it all, yeah. And so since 2007, and you know, Apple was heavily involved in this, that's when the HTML5 specification included video as a first-class object. At least that was the intent, right? So now you should be able to use it just like you can a video. With, you know, you've got nice things like the ability to set controls and turn on autoplay and mute the thing, and you got a whole nice JavaScript API to talk back and forth, and it's going to be great. We don't need plugins anymore. Except one of the things they didn't provide with the standard is a must implement codec, right? Codec container format audio. So that means that we then get into a war between, largely patent encumbered, but also the industry standard ISO, Ffmpeg, whatever formats, and then folks who didn't want to pay for every time you install their browser for whatever codecs and things they had to install. That's where the open standards come from. So nobody won the debate. There was never an official this is the must implement codec. So instead, it was fought in the browser, like so many things are, is fought in browser wars, right? So Firefox and Opera originally gave you Ogg Theora, and then Google bought onto the group that made the VP6 codec that was in Flash back in 2005. Google bought that company. They were working on VP7 or 8, I don't remember at the time, and then they just open sourced VP8 and said, fine, this is how we're going to solve it, is now there's an open source codec that we own, we can make sure it's not patent encumbered as much as we can, and we're going to shove it into the browser. Then Cisco came along and they released OpenH.264. And coming back to the question about patent examples. So one of the patent sort of things inside of H.264 is there is a max number of encodes and things you can do like that if you are selling access to content or if it's ad subsidized or whatever. And so if you are spinning up a service and that's actually a different aspect of the patent workflow. The other side, that's the encoding side, forget that. The other side is if you have a playback environment, right, like a browser. So if you are exposing playback inside of a device or whatever, then you have to pay royalties for distributing a codec. So Cisco released an open source decoder, playback mechanism, and they just paid the patent royalties for anybody who wanted to use it. If you install and use the binary, if you use their code and compile your own, you're on your own. But they paid the Ffmpeg Alliance, which is the patent group that sort of organizes all that.
So is this something you were distributing with your platform, or something you expected your end users to have already installed?
As a web developer, you hopefully don't have to worry about it. Because what Cisco is trying to do is say, Firefox, you can now ship an H.264 encoder, and you don't have to pay for everybody who downloads Firefox. So then that means for web developers, we get to standardize on H.264 without hopefully having to worry about it. That's the idea behind it.
For HTML5 video playback, the decoders are either in the browser or they're in the operating system.
So why Cisco? What do they have in this game?
I honestly forgot. They had a whole reason they were publishing it and doing that, but I don't remember. They got a lot of.
They do a ton of video.
Yeah, they have a massive amount of infrastructure in their video conferencing applications and a bunch of other things.
Like cable TV delivery.
Yeah, 2013 was a big time in video conference applications moving more and more to the browser and everybody investing in those things. So keep in mind that the WebRTC battle was being fought after the video battle started, but it was continuing on the same thing. They also had this don't have a must implement, and Cisco and other folks were arguing for H.264. So now they're sort of replaying it. I believe that was it. It was actually more about the web conferencing and the WebRTC, but you needed to have it in the browser anyway, and we just got the benefit for video playback. That's me reconstructing a memory, so it may not be accurate. Anyway, so at the end of that, we, in the video world, eventually got to settle down at least 4 bits on H.264, AAC, and Ffmpeg for container formats as the victor by, by browser availability. Although, in some environments, as long as Firefox ships with X264 or something like that, right?
So is X264 just an encoder? Did they not?
X264 is both an encoder and decoder, but it's a library, it's an open source, like the Ffmpeg.
So it's not common for Windows users to have that installed?
Yeah.
Okay.
Yeah. You could, but somebody needs to wrap the Windows, yeah.
But it comes with H.264 or something?
It's an implementation of the H.264 standard, yeah.
When you say AAC, that was originally the Apple.
So AAC is a permutation, if I remember this correctly, of Ffmpeg for part 2 of the audio, I think. So that's what AAC is, and it's been enhanced along the way.
Okay.
And it's actually been in multiple different specifications because there's HEAAC. But yeah, Apple used AAC, and Apple's been huge in the Ffmpeg 4. Like Ffmpeg 4, that ISO-based standard we talked about, is based largely on a bunch of QuickTime MOV standards. So Apple is highly involved in these ISO standards. H.264, they were huge proponents behind. So that's why, like AAC, it's MPEG-4 audio, right? That's why they use that as opposed to some other. Right? Yeah. Now, MP3 is MPEG 2, right? So MPEG is MPEG as well. It's MPEG-1 audio part layer 3, right? Anyway. So back to the initial question, video element, right? Can I just shove a source in it? Well, now we've answered what your transcode needs to look like, what your video looks like. It needs to be H.264, AAC, and MPEG-4. But if you do that, then yeah, largely, this has been out for coming up on 8 years, available in different browsers for 8 years, and we're looking pretty good, right, for standard progressive video delivery. But you still need to transcode that video because, like we talked about before, it's coming in a bunch of different flavors. It might be coming in H.264 AAC, but it's in a profile that's not supported by a bunch of the devices you want to push out to. So you're more than likely still going to need to prepare that video and maybe transcode it. So transcoding, if you're not familiar, is just the process of decoding and encoding. I said it in another form, this is wrong. It's decoding and encoding the video again. If you just change the bit rate, you're transcoding the file, right? But often we're talking about moving between formats. So in our workflow we're talking about here, we're going to take whatever input format, assuming you can support it, and transcode it H.264, AAC, and MPEG-4. And you need to understand your settings for all these things. You need to understand what your, we already said the video, audio, and encapsulation formats, or container formats. Video and audio bit rates, right? What are you targeting? What's your resolution? How much quality can you, like, what's your quality bit rate trade-off? What are the devices and networks that you're targeting? Blah, 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 blah. Compression profiles, that's that baseline main high. You need to understand the devices that you're going to. These days, main is a pretty safe bet. Most every device is going to support main. High is a lot of devices, but it's still not universal. There's still a lot of, you know, existing cable boxes that now actually have web browsers and things on them, so they can play your HTML5 video element, but give them a high profile H.264, they won't be able to play the content. So you just need to be understanding what your target devices are and then make the right profile settings. How many audio channels, blah, blah. And some of this is inspection, right? Like you pull in a video file and the frame rate of the original video, now it could be a 30 frames per second standard, it could be 60 frames per second, like higher frame rate, or it could be something ridiculous, 100 or whatever, it could be variable frame rate. So you need to be understanding the frame rate, your target frame rate, because that obviously indicates how much information is getting pumped through the video, and that affects your bit rate, right? Or is affected by your bit rate. So, I'm going to talk in a minute about Ffmpeg, but there are a lot of cloud-based encoding providers. We actually have our own encoding infrastructure. For us, we don't expose it, like you can't go and sign up for essentially video encoding API in the cloud. For us, you upload a video, you publish it to destinations, and we bundle all the transcode configurations for you, so you don't have to worry about that. And there are APIs for access and all that. But if you want control, there's encoding.com, Amazon has Elastic Transcoder, a lot of these different services provide that, but you need to essentially point them to a file, make sure that file is something that they can read, which they're usually pretty open about they can read, and then understand all of those values to configure inside their system, right? Sometimes they may give you some transcode bundles like Apple TV profile, and then you can just sort of use it, but a lot of them are essentially, you know, programming in those things across an API. This is my format that I want to use, the resolution I want to use, the frame rate I want, the bit rate. So you still need to understand that, even if you're using external encoding provider. And then you can always buy one or roll your own open source. Caveat, again, if you're doing your own open source and you're coding things, make sure you understand what your patent liabilities are. That's going to require some research. I can't answer that for you.
Is this all pre-processing you're doing? Do you ever do it on the fly?
Well, live video we do on the fly.
Yeah.
You have to do it on the fly. And so here I'm talking about what you could build. There's a number of ways you can pipe data in real time to some of these processes and then have it streaming out on the other side. You have to be a little bit, I don't want to get too deep, but the different container formats, some of them aren't great about piping video continuously through. Like MPEG-2 transport stream is a fantastic container format for that. It was designed for network-based constant streaming, generates these nice little packets, it's fault tolerant, a bunch of cool things. MPEG-4 is not quite as good for that, but people have made it work in different models. So if you're rolling your own, but like probably the number one video tool in my toolkit is Ffmpeg. It's been around forever. It includes, by default, it includes maybe 1,000, I haven't counted last time, but definitely hundreds of different codec container format subtitle format, etc. pieces built in, and it's got a whole extension system that you can compile in support for other codecs, like we've talked about a couple times. X264 is an open source implementation, and it usually wins in a lot of these encoding contests for quality and bitrate trade-off, but you can compile in X264. You can see here I'm using it. The video codec I want to use is actually libx264 that I've compiled into this version of Ffmpeg. It's got AAC, it's got Mpeg4 support built in, so it's perfect for us because it can read nearly anything. Again, consult your lawyers. So, what these different parameters are, I'm taking in this video, I'm saying make it H.264 for the video codec. I'm saying I want a video bit rate of 1.2 megabits per second, which is actually pretty low for a 720. I'm actually not specifying the group of pictures. I could do that. I could say I want a 200 frame group of pictures, or I want a 30 frame group of pictures, whatever I want. And that's the distance between those keyframes. Okay. I'm saying main profile. Now that's a whole bunch of settings that I just imported, because you saw before, like the checkboxes and all that kind of stuff. So main profile limits some options, prevents you from turning on some things that would break in other devices. So I'm just using the nice Ffmpeg shortcut. And then preset v medium is a whole bunch of other options. It tunes for a medium amount of crunching, your machine thinking about what it's doing. And so there's a bunch of toggles you can turn on to make the video harder to decode and to view, and it takes longer to encode, but you can reduce the bit rate. And so there's a whole bunch of, there's like ultra fast, which just turns off anything that's going to take very long, keeping in mind a couple other values, and then there's ultra slow, which just never finishes. So I'm making a 720p file at 30 frames per second. I'm using AAC at 128 kilobits per second for audio. It's fairly fine. That's not too different than what you might download from somewhere. I'm saying it's a stereo. This is audio channels, so 2 audio channels. I'm saying 44.1 kilohertz sampling rate. Mpeg4, I'm not setting any Mpeg4 container things yet. I'll get to that in a moment. And then I export a video file. Now, this on the other side, I can be pretty sure is playable, with a caveat, on most any system. The caveat is Mpeg4 and a number of different container formats, the way they write to the system is they're building up an index as they go through and compress this, these video bit streams, or they're reading this video bit stream, and then they drop an index of all of that at the end of the file, because that's where they are when they finish writing the file. They're right at the end, so they drop all that information there. But you need that information to play or seek into the rest of the file. So if you take that file and drop it on a web server, and you don't move that data, you have to download the entire file before it can start playing. Effectively mean you're not streaming. This is like probably thing that hits people right out the gates. They have this nice, but I heard Mpeg4 is streaming formatted, and I know everything supports it. Why does it take so long for this thing to start? Because progressive streaming is saying, move all of that index information to the front of the file. I'm going to still talk about some new, better methods of things, but this is get you started.
I know with HTTP you could start a download at a certain point in a file. Why don't the clients just...
There are actually 1 or 2 browsers that did that. Okay. They actually would see that the move atom is not present, and they would just start like hunting around at the tail end of the file, assuming it was there, and they would start streaming much faster. And it actually worked pretty well, but not all the browser vendors did that, and so you're stuck, right? You can't have this like partially streaming file.
It's a variable size, so you don't know. You can't.
There's no index.
Yeah, even if you know the length of the file, you don't know where the beginning of the
You're essentially like binary tree searching for where does this thing start, right?
Well,
and you're jumping right into the middle of a file, so you're like trying to discover where you are in the protocol.
Yeah, that's kind of sloppy.
Yeah, so it's rough, but there were a couple people who did that, and most everybody else was like, yeah, no, I'm not doing that. That's
Yeah, just move it.
Yeah, it's up to you. The Mpeg4 wrapper supports it, so go do that. So, yeah, we talked about that. There's a parameter. If you add this parameter, it used to be a separate utility shipped with Ffmpeg, but they just eventually built it in. So when I say -f mp4, then add move flags fast start, meaning it pulls it down first. It just puts all that index information at the beginning. So now we have a file. You accepted a file from somebody. You've now stored it somewhere for that permanent asset, and you can throw it away if you're done, depending on what your needs are, once you've got a playable version of it. But we have a version that is playable in the vast majority of browsers, conforms to a lot of the standard device support, and will stream progressively when asked. So we're in a good spot now. and this is just one of the, this is a video I shot in Tokyo a few weeks ago. But this is, I ran the same parameters, right? I had a 4K asset that was ProRes that I was editing, and I ran it through to a 1920 by 10, or 720p using those settings. I think I used 3 megabits per second instead of 1.2, it's a little low. But you can say there's a lot of detail on that. It doesn't look terrible, right? So, there, I wasn't lying, it actually works, right? But anyway, that's, now coming back to your application, there are a lot of considerations for these things, right? Transcoding is slow, right? Even on a beefy machine, 720p, 1080p encoding at high bit rates with high profile or some of these things turned on can be slower than real time in some cases, in some boxes, depending on the size of the machine that you want to dedicate. Especially when you're like spinning up Docker instances or whatever to make these things run, you might have reduced amount of available compute depending on how you're setting up your infrastructure. So you need to plan for these transcodes to take a while. That's not just in compute scalability, that's in UX. Are you communicating back to your user that we're off running your file, right? And we don't know when it's going to be done, right? So how do you design your application? Because you definitely don't want them sitting there staring at a, we finished your upload, please wait while we process your 3-hour-long file. It's going to take 6 hours, right? So think about that. Obviously a task system is the right way to do this. Don't do this on your web nodes. If you like your web nodes being up, don't put it on like your web application server nodes. All right. Transcoding also results in other large files, depending on your approach. If you're streaming in and streaming out, which is a more complicated problem and expects certain types of input formats, but if you build your system to stream in and stream out, like stream in from cloud storage and stream out to other cloud storage, then you don't have to worry quite as much. But if you're pulling down a file, in some cases which you have to for the same reasons we just described browsers doing that, and you're writing the finished transcode to file before you move it off, that's a lot of disk space. So depending on how you have your task system set up for parallel usage and the size of your disks and all that kind of stuff, things to think about and plan for. And that ultimately comes around to knowing your input settings, right? If you can cap the input size of the file and cap the types of formats that you're expecting or accepting, and you just tell the user, we don't like that file, please try with something we like better, then that at least helps constrain your realm of problems. Right? But that does require some inspection after the file's been uploaded. Yeah, all right. Know your input settings also so you don't repeat work. It is possible somebody has given you a file that perfectly matches your settings or at least works within the realms of it, or more likely the case, you've got this beautiful 720p setting that you've fine-tuned and they're uploading a 640 by 360 file. And you're going and blowing the thing up and using more bandwidth for no reason, right? So, just things to think about. But that's all the old school stuff, right? That's the stuff that, like I said, it's been around for a while. You're safe doing that. Progressive streaming, it functions, it works in most browsers, so that covers your safe bases. But progressive streaming has its own issues. One is if you're not doing multiple renditions of this thing, right? If you're not doing a 720p and a 360p and a low bitrate version and a high bitrate version, blah, 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 that means that you're making a trade-off, right, between the bandwidth of your average user and the level of quality that you want. And there are a lot of systems out there that generate one transcode for you to stream, and that's it. You're kind of stuck in that model. If you do generate multiple renditions, progressive streaming is very difficult to seamlessly bounce. Netflix is not doing progressive streaming when you're like moving in between quality. They're using something we'll talk about in a minute called adaptive streaming. Another issue with progressive. So we've nicely moved our move atom to the front now, right? So it can stream, but that thing scales with the length and size of the video. So if you have a 3-hour-long video, you might have megs of index data that the person has to download before they can start streaming, right? And in some cases that can mean, depending on your network environment, that can mean 30 seconds, 60 seconds before they start playing because their bandwidth is a little constrained. It might be fine for streaming throughput, but it's not fine for wait around while you download 50 megs of index data, right? So, and live streaming is just not possible. It's not possible. People have done clever things. Flash had some clever things. But for video elements and standard things that we're talking about, you're not doing live streaming with any progressive streaming workflow. So, along comes adaptive. So Apple wrote, you guys have probably heard HLS, right? HLS is one of the first adaptive specifications to really, there were ones, I guess, a little before that, but it's one of the first big main ones. Adobe added HDS to Flash Player HTTP dynamic streaming, and Ffmpeg dash is like the ISO official version, but they're all conceptually the same thing. That's why they all have the same words in their acronym, right? HTTP live streaming, HTTP dynamic streaming, dynamic adaptive streaming over HTTP, dash wins for the most, verbose way of saying it. But they all are essentially breaking up the file and building a specification where you ask a manifest, and there might be stages of manifest, for the segments, right? And these segments are very small. And they might be Ffmpeg 4, they might be Ffmpeg 2. HLS actually uses, it can now use both, but for the majority of HLS, it is Ffmpeg 2 transport stream container format with H.264 and AAC inside of it. Dash was Ffmpeg 4, HTS was Ffmpeg 4. But this is an HLS demonstration, but again, functions roughly the same. We have our master playlist, and that can have a bunch of different qualities, and it just points to other manifests. So this master playlist is very small, right? And yes, it's an M3 UA, HLS standardized on the old MP3 playlist file that you used in what's the Llama? WinApp, there you go, yeah. So, I don't know if we just aged ourselves there. So it points to your 720p manifest and your 360p and your 240 garbage quality for people on really constrained networks. And then each one of those points to a bunch of segment files, and there's timing information in it. So via HTTP, you can just fetch down this manifest file, and then you can say, I want to start at 45 seconds in. 45 seconds in is roughly this segment. I'm going to start with this segment and seek half a second into that one, and now we're going. Because these are small files, the amount of index information is by definition small in front of them, so they stream pretty quickly. Another benefit is if you need to adapt, you just wait for the next chunk, right? Okay, I keep buffering on this 720p, so for the next 5-second chunk, I'm going to drop down to 360 and see if that helps resolve some things. And that's how Netflix and other ones, they dynamically move between bit rates as you move around different networks, right? So, adaptive, it's great.
Can you talk about progressive and how that compares? Because I actually thought that's what you meant by progressive.
Progressive is a single file. It's your Ffmpeg 4 file, right? Like, here's the one you could open in QuickTime or whatever.
So there's no multiple copies on the server or anything like that?
No, you can go build your own system to do that, right? You can go and make one Ffmpeg 4 file that's my 720p version and one Ffmpeg 4 file that's my 360. But there's no way of telling a browser, hey, move between these files, because it's actually not easy to move between those individual files because you have to download that whole chunk at the beginning before you can even seek into that second file. So there's a massive, depending on the length of the file, there's a buffering indicator, it's not clean, it's not frame accurate, all sorts of things like that. This breaks those up, so you have hundreds or thousands of little bitty video segments lying on your server, which actually in some cases is better for cloud storage because you don't have to worry about max file sizes or implications of larger files in some of the cloud providers or CDN providers. But anyway, adaptive, it's great, right? Solves all these problems. Oh, also live. You can do live because you just keep adding to the end of the list, right? Now we've solved the fact that, or the problem that you can't have like a progressive file that you're continuously generating, but you're also putting the move atom at the beginning, right? Blah, blah, blah. So, talked about most of these. Easier scale storage and processing, we talked a little about. Continuously generated is that HLS mechanism. But you can also do some fun things like ad insertion, right? Oh, I've got an ad campaign. These manifests can be dynamically generated by a service, right? They don't have to be files sitting on a cloud service. So you can be like, oh, now I'm running this new ad campaign and 30 seconds into this file. Other things. So you can even tailor those things for individual customers.
And this will look like one linear video to the web browser because it's trying to download one file, like the manifest file?
Yes, with a caveat that I'm about to get into, which is not everything supports that adaptive. You have to make it support adaptive. All right. So,
sorry, I just want to clarify what you were asking. Like, does it look like one HTTP request?
No,
No.
it never looks like one
Okay.
HTTP
Right.
request.
Well, caveat. There are actually in a couple different specifications, HLS and Dash, and I think HDS, you can actually drop a continuous file and have it point to regions inside of the file. But if it's Ffmpeg 4 at the other end, you're still going to run into the same, like, I don't know, right? Like you're kind of trying to seed some of the index information into your playlist file, and it functions, but it's not always, like, there's a reason why that's not usually the way it's done. And Ffmpeg 2 transport stream handles that much better just because it's a network-oriented protocol, so it breaks things up nicely along the way. I'm a big fan of Ffmpeg 2 transport stream. It's old school, but it's nice about some of those things. But still, yeah, it's going to be multiple chunks. It's actually nice because you can debug efficiently too. You can see when you upgrade and downgrade your streams.
Sure.
Yeah.
So it's not like an upgraded socket connection or anything like
No,
that?
no,
It's
no, no.
still HTTP
This is
request?
pure HTTP. It does get some benefits from HTTP too, but it's still like just pure HTTP. I'm making a bunch of requests.
Even like Netflix is doing that too, right?
Yeah, yeah. Well, I mean, it depends on what point in time we're talking about that. When it was Silverlight, it had a whole bunch of other deal. But yeah, by and large, they've standardized on Mpeg Dash and a couple other things, and they're doing a variation on this. Yeah. All right. So you can still generate these with Ffmpeg. I'm missing one step here, which we'll talk about in a second. But I'm taking one video in, and actually because I'm providing these values and I'm not changing them too much, it should be somewhat frame synced and things. There's things you can improve. Thomas is looking at it right now. They're like, you can fix some of those commands. You don't have them all. But the main thing that I'm missing is I have a 720 playlist here. All the other values are pretty much the same, right, that you're looking at. And I have a 360 playlist here. But I don't have my index that points to both of those. So you have to kind of manually craft that, but it's a very small file. Yeah.
So is this going to output like a directory of all the necessary files? Okay.
Well, this is going to just dump it in whatever directory I'm in, but yeah.
So that M3U8 isn't a container, it's a...
Nope, it's just another file that sits on the drive.
That's the index file.
Yeah.
Okay.
It's
So-
a text file, you can open it up in Vim and see what it looks like.
And everything else is stored alongside it, I guess?
Yeah, so I've got one of these. It's a very small file, but you can see here it just prefixed it with 360.
Okay.
It's very small, so it has a single digit for the number of chunks. And then there's my 720, and you can see I actually have my MP4 file too, but the M3U8 is there, and the M3U8 is there. That's how it functions.
Can you zoom in on that?
Can't read that?
But you could also open up the M3UA file, and that might be useful.
Yeah, that's a good idea.
Yeah, please.
So this isn't the index file. The index file would just be a very short pointer with some information about quality and bitrate and all that kind of stuff. But
Okay.
that's what if you've seen Mpeg 3 playlist, it's the same thing with some extensions, right? So it tells me my timestamp offsets. The reason they're a little funny is because where it can, it uses keyframes, right? If it can. It's always nice to have one keyframe at least per segment. It's really nice when they start with a keyframe, but whatever. So that's E3U8, that's HLS. Dash functions somewhat similarly. It's actually a much more extensible protocol. It's an Mpeg, it's an ISO standard. It makes sense, right? Like they over-engineered it to the max. Not really. It's used in cable systems, and that's the one that the film and video industry is more focusing on, whereas HLS is where the consumption environment, the mobile device electric stuff is focused. So, great. We now have a way of generating an adaptive stream. So, and I've mentioned that I still need an index to make that work. However, now we get back into our other problem, which is not every browser supports HLS natively. In a perfect world, you'd just be able to point every video element to HLS or Dash or something like that, right? Hey, source equals, instead of my MP4 file, index that in 308. Unfortunately, it works on mobile devices, works on Safari, works on Edge, and that's largely it. Right?
Chrome for Android, but not Chrome desktop.
Yeah, that's interesting.
Yeah.
So the heights of each bar, does that represent how long the release has been out?
I like the usage relative model. Yeah, so
How
normally when you go
popular
to, this is, can I use, right? Normally when you go there, it shows like a history view of versions, but I like looking at it from a, what's the relative market share
Okay.
of it. So that's all it is. And obviously Chrome for Android, pretty popular browsers. So, and yeah, it's really funny that they implemented in the Android because
Yeah, it's like
they don't have a
Chrome,
mechanism.
Chrome isn't doing it like the Android OS is doing it.
Yeah, Android has
So, like,
HLS
Chrome
in
is
your browser.
giving the operating system the HLS stream and the OS is decoding it.
So even before they started shipping Chrome as a browser, right, it was supported in the Android browser. Yeah. Anyway, but that sucks, right? So now we've got to come up with an option. Dash is a really sad story, right? Like Edge is the only thing that supports it, and now putting on my biased opinionator hat, that's because Microsoft worked closely with Netflix and with other people who wanted DRM, and Mpeg Dash is very strong in the DRM camp, right? Like how to deploy DRM as part of your content. Not a bad thing, but that's why Microsoft is supported for you can output DRM is a whole other conversation. Like, we could get into that. It's a whole different set of extensions and things in the browser and state. But
And this is native, you don't have to have Silverlight or anything like that installed, right? 'Cause
this is native. Yeah,
Okay.
like without any plugins, what's supported. Nobody supports Dash except for Edge, and half the market doesn't support HLS. So you have to figure out something. Now, before media source extensions, your figure out something was Flash, right? That's the only other thing that you could go and build something that sort of made it work. But media source extensions came out. Oh, I forgot the year. This is like 2013, maybe? I'm forgetting. Google works, you guys can look it up. It's a lower level JavaScript API. So we had our nice clean video element, but it largely abstracted everything about the internals of playback away from you, right? It's like, it's got some JavaScript events. Sometimes they work the same way across browsers, and sometimes they didn't. Oh, I forgot to put this slide. One of my favorite things about the video element thing, or the audio element or the video element, is it has a can play type method that you call in, and you pass in a string that's essentially describes the file, like your MIME type and some of the format codec things inside of it. And it comes back with three very, very computer science terms. It comes back with probably, maybe, no, and an empty string. And the no or empty string is variable.
I don't think I've ever seen no. I've only seen empty.
It's in the specification.
Yeah.
Maybe nobody actually wanted to say no. You never told the user they're wrong, right? Anyway,
What does this exactly?
this is I have a video file or an audio file, and I want to know, does this browser support it?
It's the HTML5 spec for how the JavaScript can ask the browser if it supports
It's still that, yeah.
the
That's the
format.
release
So
specification.
HTML5 actually knows
Yeah.
all the codecs, or?
No,
No, it only reports what's installed in your operating system or supported in your browser or whatever, right? It ties into that lower level API. So if it doesn't know, then it answers no or empty string. If it knows it but it's not really sure whether or not the profile or the parameters are supported by the device, that gets into like baseline profile, main profile, some of those things, then it'll come back and say maybe. And then if it knows it and it understands the values and it's pretty sure it does, it still doesn't commit. It says probably, right?
So this isn't like running Windows Media Player or Totem or anything like that in the browser.
This
right?
is pure
the
HTML5 video JavaScript API. So I forgot to put a slide in there because that's video in a nutshell. Probably works. Let us know if it doesn't. Here's our support form. So anyway, so blah blah blah. Now we're extending the format because there were no low level. It was a black box minus the control JavaScript layers and the event JavaScript layers and some of those things. And actually, Tony, you know some of the incompatibilities very well. I'm just remembering. Yeah. So anyway, media source extensions comes along and it allows us to now talk to a lower level component. We can feed raw, essentially bitstream chunks to a player, right? A lower level element of the player, and that means that now it's up to us how we want to pull those things down from the cloud, right? So it still needs to be like if I'm feeding it an Mpeg 2 transport stream chunk, the browser needs to understand Mpeg 2 transport streams and needs to understand whatever video codecs and audio codecs are in there. But I get to determine what kind of network requests I make and whether I'm pulling it down off of a WebSocket or a HTTP request or something.
generating it.
Yeah, I'm generating the file locally. Yeah, exactly. That also means that I can put some logic in between when I fetch it and when I pass it into the player. So if I need to rewrap it in something that the player understands, or I put some sort of encryption on it that I want to decrypt in memory in the browser, all things that I can go do. So media source extensions is kind of nice. So you're able to do most things that you can. And this is a fair point to say what's slowly happening is that we're reinventing everything that was available in Flash, because you could do all of this Flash back in 2003, back in 2004. Anyway, but it too isn't available everywhere. Much better map, especially when you overlay it with HLS, right? So you get most of the world, because iOS and iOS Safari specifically doesn't support media source extensions, but it supports HLS natively. So if I can make my browser understand HLS and all these other things, and it supports it natively here, I'm good. So we're 100% great, unless you happen to like IE users on Windows 7. Because they ported media source extensions back to they gave it to IE 11, but only on Windows 8 and Windows 10, because they hate us, right? Like they just want us to maintain these matrices on our walls where we have to remember this. And this, I can consistently forget about this. Like just the other day, I was like, oh yeah, the Windows 7.
Well, it's also weird that like I think Windows 8 is also missing something that Windows 10 has in IE.
Yeah.
It's like this ramp of like adding support, and just like a cut.
So if you can cut off IE 11 on Windows 7 as support, you're golden. You got everything you need. If you need to support IE 11 on Windows 7 or anything older, you got Flash, right? That's what you got to go back to, because it doesn't support HLS as adaptive. I mean, you can use progressive, right? But if you're needing any aspects of the adaptive or you want to standardize on it, you have Flash as an option, or it's your only other option. So that's a adaptive.
So Josh, the
yeah.
extension, the MSE, that's not a browser extension, is it?
It is a browser. Yeah, it's part of HTML5. It's like a
Okay,
specification.
It's not like an extension.
I,
Like
the
a
user,
Chrome
don't
extension.
have to, don't have to.
You don't have to
Okay.
wait. It ships. That's what I'm saying. It's like these browsers ship
Got it.
with MSE support. Yeah. And so now, but we still need to do some work, right? Because MSE doesn't support HLS. It supports a mechanism of passing video chunks and audio chunks to the browser. So you now have to do a bunch of work. I recommend you don't go unless you really want to, because it can be fun. You can do some clever things. But if you're trying to just support HLS or Dash or something like that, you've got a couple of open source options here. HLS.js, really solid tool. It's supported by Dailymotion folks and other things like that. Dash.js is the reference implementation by the Ffmpeg Dash group. Shaka is the Dash implementation largely fronted by Google. So that's their sort of open source library. But these are all options, and they're designed to expose a fairly straightforward video interface. Use a player or something like that inside the browser with a little bit of JavaScript. So, recommend using one of those if you're going to do adaptive. Yeah, blah, blah, blah. I just settled that. So this is just the same video, but now it's using adaptive. If we measured it, it probably started up slightly faster. This is all pulling off my local machine, so only the machine could measure that speed increase. But, great.
This isn't a web page right now we're looking at, right?
This is. Yeah.
Okay.
Yeah, this is just a
Your presentation.
Reveal.js, yes.
Okay, cool.
We already talked about that. Still need Flash. Okay, so you now have video inside your app, right? You not only do you have video playing in your app, but you have a nice, sort of somewhat modern way of streaming that video. This is just some of the stuff that you need to be thinking about in your application, right? Now this is my pitch slide, right? This is why we built, I think I have this. Yeah, that's why we built the platform, right? Is because in reality, we've been in video a really long time, and this is what you need to start playing video. And for a lot of use cases, that may be all you need, right? Like, for whatever reason, we just need to accept this file and turn around and show a preview, and we're doing some simple CMS or whatever, and maybe you want to roll that on your own. But one day, you're going to need to get to the point, most likely, of how do I manage metadata, especially if you're sharing files amongst people, how are we extracting information like transcripts from audio files and, facial recognition, all sorts of fun things like that. How am I customizing that player experience? I haven't really talked at all about that JavaScript API, but unless you really, really like how Chrome looks with their control scheme and you don't want to add anything, and also you like Safari and all the other ones, you're going to probably want to layer your own system on top of it. And it's all CSS and HTML, you can do all that, but you got to go build an adapter layer for all those things. Anyway, lots and lots and lots of stuff. How you track it? Like if you have video playing but you don't track it, doesn't matter, right? Some of those things. Authorization and protection is a big one for some use cases. For a lot of marketing and public use cases, maybe you don't care, but if you've got sensitive content, you can do that. So.
Well, what does it do?
Say again?
What does this component do? Like protection?
So protection, I'm calling it there, like, it can be DRM or it can be somewhat more lightweight protection, but just preventing people from being able to take the file and run with it, either pulling it off of the server or encrypting it or doing something like that. You need to be thinking about how you're protecting your content from being able to.
So what does it do basically? It just scrambles your file, so each time you ask the server, it points you to something.
It depends on which protection scheme you want to go for.
An example.
So the DRM that you can get right out of the browser, yeah, it scrambles it so only your hardware, well, depending on the DRM solution, but only the hardware on your machine can decode it, right? So you're using like Wi-Fi or something like that, and you're encrypting the content. You can do like more simple models. There's actually common encryption, so you can do it pure software. You don't need to use a vendor, but it's easier to decode if you get the keys. And then it's all the way out. I say authorization here. It's all the way out just to making sure that you're verifying your user's cookies before you allow them to pull it down, so that they can't send a link to somebody else and they can start streaming it, right? That's the continuum of very short, it's a continuum of security you might need to be thinking about for your application. But it depends, some people don't have any protection up front. Live streaming, I talked about how you can kind of accomplish that with adaptive, but it has its own whole big issues. If you need to put review workflows because people need to approve it. If you are accepting upload from the general world, you're probably going to want review in there somewhere, because if you allow anybody to upload video, you're going to get video you do not want. That's just the way the world works. So, little story, should I tell that? Yeah. So we used to have a video wall where inside of the office where we would show whatever our users, and these are like users allowed to,
Paying customers.
paying customers allowed to do it. And there we had some healthcare clients, and they had prostate surgery. So turn that on. Yep. Anyway, and these are like public marketing things like that. It was just.
That's not a HIPAA violation?
No, it was like, they were like, it was like an ad for it was like an ad for doctors, like, if you buy this, like,
Yeah, this was
your
not
prostate
HIPAA.
surgery will go faster or something like that.
Yeah, this is like all fine.
Interesting.
It is part of their
Yeah.
marketing materials, right?
Wow.
Which is kind of scary too, because you're just like browsing somebody's healthcare website. Whoop,
Yeah.
autoplay, right?
Yeah.
Anyway, but so just that's all good. Like paying customers uploading 100% fine content, and still you got to be careful with how you play. If you open it up to the world, that's Anyway, so now we can talk a little bit, and very little bit, because I'm really long-winded tonight. Sorry. Changes on the horizon, things that are coming down the pike. Like I said, video is evolving. So we've been in a nice little bubble of H.264 and Mpeg 4 and AAC, but there's a lot of shifting happening right now, because as we're going to 4K, as we're going to VR and all this kind of stuff, it's more and more and more data, and H.264 just isn't being able to hold up. So you have
What's 4K?
4K, sorry, 4K is the horizontal resolution. It's a round number because they're actually like 3,800 whatever pixels wide. But it's just, if you have full HD, 1080p is the, it's fun because 4K is the horizontal and 1080p is vertical because we can't keep our standards in line. But 1080p full HD is what like a lot of HD sets at home do. That's like their maximum resolution. 4K is the next level, and it's roughly 4x of the information, much higher resolution. That's a lot more data, right, coming down the pipe.
3840.
Yeah.
It's the resolution.
Yeah, it's
Of the video.
3840 by
Yeah, it's called 4K because 4,000 pixels wide, right, and 2,100, 20-something 100 pixels tall.
So it's like 1.5, it's like 4 times the size, no?
Yep. It's essentially 4 1080p.
That's what
frames. Yeah. So that's a lot more data, and we're running into the edges of H.264. Even though you can get 4K, it's running out of steam. 8K is not actually ridiculously far out there, and 8K just, can't do some of the same things with it. So HEVC H.265, as it's known by a different group, Mpeg H Part 2, because it's got 3 names like everything, was ratified in 2013, and that is the sort of the darling of the ISO standard industry and of again, like cable distributors and boxes and things like that. VP9 was the follow-up to VP8 by Google. It's in Chrome, Firefox, a bunch of different places, and it's a more efficient version of VP8 and actually is improved over H.264. And so that's out there, and you can use it. AV1 is exciting because AV1, a lot of people have been doing their own like video codec work for a while, right, and sort of iterating. Mozilla was doing their own, I'm forgetting it, they had some clever things they were doing internally. Google obviously continuing to do their work, and Cisco and a bunch of other people. And so they all joined up, and for the longest time, AV1 was with everybody that mattered except for Apple. This is only just some of the names. But like in December or November, Apple joined the AV1 board. Now that doesn't mean anything yet. It doesn't mean they're going to roll out AV1 to their iPhone 15 or whatever when it's ratified. But this is an open source group, all of them working in the open on like the next generation codec. So AV1, it's a hype thing right now, but it's pretty exciting, at least for somebody in the video industry. So we'll see what happens there. And as always, none of this really matters unless you have hardware support. So H.265 hardware support is getting out there. Chrome has been pushing, or not Chrome, Google has been pushing VP9 hardware support for a while too, so that's in some Android devices, right? Things like that. But on your desktop, on your laptop, that's, you know, on your decent laptops, you can do some software decoding of these things, but it's going to kill battery, it's going to take a lot, your fans are all going to spin on. You want the hardware support in graphics cards, you want it in your mobile devices before it's really going to be, before we can really say it's arrived. At least that's my definition. You can go and make your own decisions, but that's how I look at it, is hardware support. So new experiences, we talked about some of this, but 4K, HDR, that's the higher bit depth. There's a variety of things, increased color gamut, all sorts of cool things with HDR, but more sets are being bought in the traditional H.264 8-bit, won't get you there. So you want to be looking at that. VR headsets, 360-degree video, a lot more information, so we need better compression formats. And actually WebVR is a, for those of you who don't know, that's a draft specification for like putting on a headset and it talking to your browser, right? So great, now we're building whole new player experiences, right? So your traditional little video element, not gonna cut it. When you think about Canvas applications and how we're building out 360-degree VR experiences. And then we talked a little about WebRTC peer-to-peer is just pushing sort of different experiences as well. So this is a thing we've said used to be for a long time, but the only constant with video is change. It has continued to change from the dawn of digital video. The web only adds layers of complexity to it, and it will only continue to change. And actually the last probably 5-10 years have been sort of a nice, sure there's been the Flash disruption and HTML5 video and all that kind of stuff, but largely from a format perspective, we have all gathered around a limited distribution set, and we might blow up into another war, right, where we have to generate for AV1 and VP whatever and H.265 to get what we need to. So it's fun on the horizon. That's my very long talk. If you're interested in like, if you look at this, right, I hope you guys all play around with video and try that kind of stuff. But if you do get to the point where you're like, this is all great, but I want to, you know, I'd rather call it REST API than write all this myself, come talk to us. We have APIs for all those things. I'm going to put up the slides for all of this pretty soon-ish. No commit. I don't give deadlines. But you can find it at my GitHub whenever I get it out there. So.
Thank you, man, that was cool.
Do you see like Encoder or anything like that?
Yeah, well, so the fun thing about it is Encoder and a bunch of the other ones, they actually use libav codec core, which is Ffmpeg. Okay, so there's a lot of nice, there's a lot of the encoding tools that you use are pulling in libav codec or pieces to do their encoder, decoder, at least part of it. And so I don't use I use Ffmpeg, but there's like, what's the desktop one that everybody likes? Handbrake, that's the one. Yeah, Handbrake uses libav codec and things like that on others. So, yeah.
This is kind of a longer question.
What's up?
Maybe you can ask it.
You can ask yours.
Well, mine was about your ingestion pipeline and pipeline. I was kind of curious how you're doing that. You said you do some checking in the video file before uploading that. I guess you do that in JavaScript.
No. Well, yeah, I should say, we do a lightweight inspection on the browser, but like I said, your MIME type.
Like try to read the container and figure out.
We're not even doing parsing there. So we have to accept a lot of different video formats just because of the range of uses our customers. So I'm providing that to you guys to guidance because if you can restrict that, it reduces the complexity of the system you have to go build. In our model, we pass it through our system. We make the assumptive that we can handle it. And then in the event that for whatever reason we can't, that's when we come back and we tell the user, hey, you gave us an asset that doesn't work. So that's our system. And then it updates metadata and fires webhooks and things like that.
Okay, so when a user uploads the file, it's not going directly to your storage server, it's going to the intermediate proxy, right?
It is well, it depends on the application that we're talking about. We have live streaming and other things that do, but largely there's
like a HTML video upload from.
Yeah, they're doing HTML video upload. It goes through our system. It goes very quickly to cloud storage. Now for us, we allow our customers to specify cloud storage because in some cases they want to own it, right?
Like their cloud storage.
Their cloud storage. In some cases, not even cloud storage. It's the storage that they want to give us access to this network. But that's one of the features of our platform. So along the way, we're doing the right thing to, inspect it, make sure it works.
Does it make sense to do any kind of compression on the client? Because if you're uploading just like massive, something with a tremendous resolution, but then the end product is going to be pretty small.
It does make sense. It's a little bit of a challenge in a pure web model. There's a lot of actually client applications that do that. They have the video management layer, and then you're like, ship it off to my backup, and it's like, cool, we're going to go process it, reduce it to 1/4 the size or whatever, and then ship it off. My background, at least, some of my background is post-production workflows, and so there's a whole thing called like offline and online mode, which has nothing to do with the network. It has purely to do with a reduced size, because you can't edit like 8K masters on your laptop on the go. So you have that sort of model and you upgrade it later. And so those kind of workflows work pretty well too. You bring in all your clips and you're like, hey, go generate all my offline clips that I can go edit. And then sometimes you can send those up to the cloud. So there's a couple of workflows. Does that answer?
Yep.
For that proxy server, is it running something more like Twisted, where it's asynchronous, or something like Django?
We do a lot. We don't run Django at UStudio. Those of you who know me know I've been a Tornado fan for a long time.
So Tornado.
So, yeah, we run. I say, I can't own it anymore. You guys make the decision now to also continue using Tornado, so it's not just my fault anymore.
Yeah, well, like with the raw video upload, we're not going through Tornado, we're just going through Nginx.
Okay. Yeah, we're usually fronting our Python processes and things like that with Nginx or whatever.
And there's different ways to do it, because like you could be,
Well,
there's a bunch of trade-offs that you're making, right? You could be, downloading it to the disk and then inspecting it locally, but then if something happens, it's gone. You could be taking the chunks and as you get them, sending them to cloud storage. There's a question of, do you want to be doing the inspection? Inspection's not like that computationally expensive, but it still has to decode the video.
Yeah, I'm more worried about moving the video around.
Right, so like, do you want to be doing the inspection on the box that's also accepting other people's uploads? Like maybe you don't.
Yeah.
So then you need to put it into cloud storage. You need to put it somewhere where then another box can go down, like access the content.
And when you start thinking about scalable upload by like for resumable or chunked upload, you don't have access to the full asset. So you're kind of painting yourself in the corner if you are expecting a lot of that inspection to happen on that local device.
Well, I was thinking about maybe using or having your users upload directly to S3 and then using something inside of Amazon to process that from S3.
Yeah, that's a fine workflow. Just when we've evaluated it, and we've actually had other utilities that have done things like that. But when the end user is uploading, that's why I was talking about progress and error tracking and all those kind of
And
things.
S3 doesn't support any of that stuff.
It's like it has these nice like generated signature accepts a post, but it doesn't say like here's a hook that we're going to call, so then you can update your UI.
So if you want like a JavaScript, widget that's like you're 23% done, or it died 23% in, so start over because it's going to take you 4 hours to upload. Like you can't.
Yeah.
It's very difficult to do against AWS.
Okay, you'd have to like kick off an event from S3 or something once the file is uploaded.
But the file might not be uploaded because they might have closed their laptop, right? And then it never got uploaded. So there's all sorts of issues. Like it works, but there's a lot of sort of corner cases that are harder to deal with there.
Okay.
But it does, like, it definitely takes a burden off of you. You don't have to handle all of this content coming into your servers, for sure.
Yeah, I didn't think you'd be able to really architect it and take all the video directly and then re-upload it. I thought that'd be too expensive to do from a bandwidth perspective.
Well,
It's something we've
AWS, I think, charges you for bandwidth either way.
Okay.
If there's
Even pulling from S3 to run in their computation.
but remember,
Actually,
the
bandwidth
user's
in.
browser isn't in S3. The user's browser is somewhere else. So
Yeah,
you're still paying.
You're always gonna have to
Yeah.
do the first upload.
Right.
And
But yeah,
then
like
it
if your server's running inside AWS, once it gets to your server, you've paid the ingest bandwidth, and putting it in S3 is the cost.
That's true.
When you have to pay ingest bandwidth.
Yeah.
Cloud providers are often pretty friendly about you putting stuff into their system because you're paying for it somewhere else.
They know you're gonna. You
Eventually
need it
more.
out. Like there's no reason to just put it there.
Yeah, and the amount we would pay for, ingest is not our bandwidth. We have customers like Universal Music Group who have global launches of video, like outbound bandwidth. When you have a big video project or you have like distribution,
It makes sense at a door set.
your CDN bill.
Yeah.
If one video is getting one view, then maybe it'll be less, but as soon as that video got 4 views, you pay way more on the outbound than inbound. So
That makes total sense, yeah.
Yep.
You mentioned at the end VR, you talked about all those goggles, but let's take it back in time. IMAX, when it came out, it's just a digital format. What does it use?
IMAX?
IMAX is not the digital?
No, IMAX is 70 millimeter. I mean, there's digital aspects to it now, but it's yeah.
It's not okay, so let's take it to another those 3D movies that they show you. Those are digital projectors as far as I know.
Yeah, it's all digital distribution now. And so there's specific high quality format. I used to know what
Yeah, but is it like?
But they're like, they give you
MPEG
2 hard
or
drives to plug in the projector. Right? They're not
Is it
streaming.
within an MPEG or whatever it is, or?
So again, I don't remember exactly what's on those drives. I just know that like digital cinema, they ship drives more than.
Compared to those 4K that you're talking about?
Yeah, they are
Is that-
4K. They're 4K. They're 8K projectors.
Ah, thank you. This is what, so basically what you're saying is that home TV will become like what IMAX is now.
Exactly.
Okay, and this is what you're saying, and when the video today is transmitting something which is 3D.
Yeah.
So, what's today, what formats are available today for 3D? And
Oh, for 3D.
how does it work? Because
So 3D is fun, yeah. So you've got like standard old anaglyph, right? Like the red, like you wear the
Yeah.
red blue glasses.
So this is
and
the
that's-
code
that's-
that's in color, this is easy.
Yeah, anaglyph is easy because it's 100% the same representation of video, right?
Got it.
So then you start talking about like,
Interlace and,
yeah, exactly. Like there's actually a lot of different workflows. So there's some specifications that are actually specifically about shipping your stereo images inside the same container format. But a lot of times it's actually done more simply to keep timing and things, that they'll actually stitch them together so you get a super wide, and then it's on the device, it's like extracted back out.
Okay.
Yeah.
So basically you have one frame that has both of them and it's cut down.
Yeah, super wide and they extract per frame, right? And that's got to be pretty quick if you're talking about like 4K source, but it's now 8K wide.
Right, hardware can do this today.
Say?
Hardware can do this easily.
Hardware, yeah. Like, well, it depends. Yeah. Like your VR headsets that are the high-end ones, yes. If you try to do this with like your Android-powered one, bad time. Yeah. So, like I've done 2K VR. I don't do much stereoscopic just because I don't know. But because it's hard to produce, right? You've got to have the right cameras that are set up for it, and so most of the folks that we're working with in VR, they're not like cinematic. We're strapping 2 reds together and going and shooting it. They're experimenting with 360-degree video, and maybe they have a one decent rig, but they're not doing a lot of stereoscopic. That's just for us right now. And even still, a 2K non-stereoscopic 360-degree video, like that's already kind of gross. So, yeah.
So they don't use like one frame and then map it to like a geodesic or anything like that to get.
That's what you do. Well, that's the naive approach, right? You take one frame and you turn it into the map style, forget the term for a moment. But
Mercator.
exactly. You have a projection of it and then you invert it. In reality, taking a sphere and mapping it to a rectangle is hugely inefficient.
Mm-hmm.
That's why Alaska is so big, right? on the maps, right? It's a bunch of redundant information. And so there's a lot of work. Facebook actually has some great stuff they've done in the open on optimizing. It started like cube mapping. And so you actually have 6 faces of a cube. You map it to the cube, you drop something in the middle, and it's nice. But then it's even got to the point where you optimize where you're sending, think adaptive, how we do that with like different qualities for your network, but instead of adaptive for your network, for the direction you're looking.
Okay. Yeah.
Right, so stuff behind you is garbage. And that requires, well, some pretty slick stuff, because you can whip your head around pretty quick. So you have to kind of predict and watch what people are looking for, and then send it ahead of time in case they ask for it. It gets fine. That's VR.
And the file's bigger.
And they're enormous, yeah. And it's stereoscopic, right? So now we've got twice as much data at this increased resolution.
Oh yeah, geodesic.
Yeah.
So it makes me cringe when someone takes a video and rotates it 90 degrees, because I don't think I'm wrong, but I imagine they're just losing so much of the content. Maybe the quality's going down.
You know, like when they shoot a portrait video?
That's actually inspection,
Like
because they don't lose any data.
Yeah, there's no data loss.
No data
It's just a
loss.
poor.
There's a flag in the file that says, draw this sideways.
So the
Yeah.
sensor is actually square.
No, the sensor is a rectangle,
Okay.
and it says, draw this sideways.
Well, so but if
Yeah.
you get the video and you use some other software to rotate it after the fact, is that lossy?
Well,
It depends on how you do it.
Yeah, it depends on what you do. Like, if you're saying, if you're talking like the standard YouTube, or like what the YouTube problem used to be, where you'd upload a portrait, but it would show it to you in like a 16:9, so it's got these giant black bars on it. Generally, nowadays when people are doing encoding, it's not a universal, some of our competitors do this the very wrong way, which I'm happy about. But they'll actually put the black bars on there, or they'll limit their transcode some way to do it, and that's just garbage. You can
That's
encode, see?
Sorry, that's called letterboxing, right?
Letterboxing, top and bottom,
Okay.
and it's it's late, I guess. My head's broken. I'm forgetting the term for the black lines.
Sorry, I didn't mean to interrupt you.
No, it's fine. But yeah, there's bars on the side. There's a term for that, and then there's actually a term that I'm forgetting for when you really bork it, and like you've done it twice, and you have letterboxing and your gutters. I think borked is just the term for it. But yeah, like that, you're throwing away information. You're encoding a bunch of black space, which you're not using a lot if it's a decent codec. But still, it's just throwing away stuff when video players, all of them are pretty good about scaling the video to fit with it.
So maybe I'm wrong, but I thought what you talked about before with, and maybe the compression doesn't work the way I think it does, but like I thought it was with like run length encoding and things like that, like kind of, encoding a block that has to be oriented this way. So as soon as you rotate it now, encoding it in the other direction kind of.
Your imager on your phone doesn't care. Like it doesn't. It's shooting it just like normal, right? It's recording it the exact same way.
Sure.
All it's doing is it's looking at the sensors on the device and saying you're 90 degrees, so present at 90 degrees. And then the player on the other side, if it understands those rotation mechanics, is just rotating it in place. It's a little bit more of a decoder, but you're not losing any data. When you make that decision at transcode time, because you're going to devices that can't rotate it,
This is what I'm talking about, yeah.
yes, or when you're the other way is your transcode workflows could interpret that. This is like what we do. We tend to transcode in the direction of the shot, but we don't store that flag. We rip that flag out and encode it the right way, but we're not losing data because it's the same resolution. It's just a vertical oriented resolution versus a. Does that make sense?
Sure, yeah. So what about something like, I can't remember what it's called, but like where you make something in the image still and everything else kind of moves around behind it, so now you're,
Oh, I forgot the term. I know what you're
We
talking
make
about.
something in the image.
so there's a, yeah, so say that like you have a video and like a flag is flapping, so instead what you do is you freeze the flag in place and now the rest of the video moves.
Oh yeah, that almost. But now that's usually done. You can, if you're doing the software, you're throwing away data. Like by definition, you're cropping in, and you're like there's just material on the outside that's getting cut because it's no longer rectangle, right? Shifting around when you're doing point tracking or whatever. But you're usually doing that in a post-production environment on your phone. You're not doing that. We wouldn't be doing that in the web application. You could. It's definitely a service that you could provide. And like, hey, here's a preview. Pick the track points you want to, and then you run.
Are you talking about
tools.
motion stabilization, or are you talking about?
Yeah.
Okay.
Yeah, that's what I was understanding. Yeah.
So I guess the real question is, it sounds like these resolutions are all large enough that I'm not going to notice. There's probably some loss, but it's not that big a deal.
Well, that's when I get opinionated about your phone. I don't have I come from like a more of a digital film appreciation
I
background.
mean, I'm not talking about phone specifically. I'm just talking about rotators.
So
I'm talking
if-
about encoding and compressing in one orientation, and then viewing and transcoding to a different orientation.
So if you're talking about motion stabilization, some of those things, if you're talking in the higher end productions, they're shooting at 4K or 8K. They might be distributing at 1080p. Yeah, you've got a tremendous amount of leeway, which you can cut out and still make that look good. Yeah, you're usually cropping in at least some in those sort of productions, things like that. With your phone, you're really limited.
So when it comes to the resolution, when you shoot a vertical video on your iPhone, usually what it's doing is it's recording a 1920 by 1080 video with a flag that says, when you show this video, show it sideways. And then the decoder has to like split the pixels to the frame buffer in a different way. But what you can also do, like what we do is when we get that in on the other side, what we say is don't output a 1920 by 1080 video, output a 1080 by 1920 video. So you've got all the same number of pixels. You haven't lost any pixel density. We've just said, okay, standardize it. Don't worry about that flag to tell the device to render it sideways. Literally, like write the pixels out 90 degrees from the way they were. You're not throwing any pixels away, but you are writing them out in a different order.
You're not doing a second compression when you do this.
Well,
literally
You are.
You have
Anytime
to
you're
do-
transcoding, you're doing a second.
You have to do the second.
Yeah.
compression,
Well, I say, anytime you transcode,
Right.
Yeah.
I could pass in here in that Ffmpeg command line, I could say vcodec copy, but it will not do anything to that H.264 bit stream, meaning rotate or anything. It's what it is.
And you couldn't rotate the video.
You can rotate the container, like tell the container to rotate it, and it's just a flag on the outside, but that's,
Yeah.
you're not actually fixing anything, on only certain devices do that.
But that's still not a lossy operation, is it?
the copy and flag on the containers is not.
If you wanna,
Well, you're
if you
not
wanna,
doing a copy,
if
when
you
you're
wanna
actually-
rotate, if you wanna rotate the video, like if you wanna literally
Yeah,
rotate the video, you have to decode it into like an RGB
Oh, yeah,
image,
yeah, okay.
and then write it back out, and then when you're writing it back out, you gotta
It's
re-encode
lost.
it.
Okay, yeah, that's.
And it's fair to point out that when you rotate it, the motion vectors are different, right?
Huh.
So it might, even if you crank out the bit rate, it might not look as good just because of the mechanisms of movement and the way the codec works under the covers. Theoretically, it should be roughly the same. Obviously, you're doing the second step of encoding, but you are rotating everything about how it's predicting motion and how it's tracking and all that kind of stuff is getting rotated. So it is going through somewhat different paths. But
I guess my bigger question is basically anytime you use any kind of real transcoding is probably lossy, and it seems, like, do you ever have any reservations about transcoding, or is it all?
oh yeah, I'm number one on like let's transcode as little as possible. So we inspect things and we say, hey, you're already in the right. I mean, this all work that we've done on our platform. But when we can be efficient, we'll copy the bit stream around, but we'll not encode it if we can help it, just so we have redundant copies and nice things like that. But if we can not transcode it, we're gonna try that.
It looks better and it's cheaper.
Yes.
Mm-hmm.
Yeah. And I'm a stickler for looking good, so or at least looking as good as we can. So.
Do y'all still use that task queue system that you
We do,
talked
yeah,
about?
yeah.
Okay.
Yeah, I mean, we have a bunch of different services now. Like those services all use different things. There is still parts of the system that you can look at. Yeah. He'd get to talk on that because he's doing great.
Yeah, there's, that talk, I was just looking through Capital Factory's recorded videos, that talk is on, if anybody's curious about the task queue that they use to do it, it's an alternative to Celery or something, if you wanna.
So specifically, we built it in response to some issues just with video processing
Right.
and some of Celery's assumptions, which we talk about. Or you
I
talk
think it was
about.
like 3 years ago, but
It was a long time
it's
ago.
up on Capital Factory, on their YouTube channel, if anybody's curious.
What's it called? Sounds interesting.
It's called Blue Q. Well, the queue is called Blue Q. I don't know what the library. I don't remember what the talk we called it.
I don't either. I could dig it up. or-
How to reinvent
Yeah.
the wheel.
Yeah,
And-
right. So you want another task queue, I think.
yeah.
I think there's another question, but I think we should,
Okay.
9 o'clock is generally when we need to get out of here, so.
Sorry.
No, I really appreciated the talk, so thank you guys. If you park downstairs, you can get parking validated, so it's only $5 and not $50 or whatever the public charge is. And next month, we'll be here again.
Volunteer.
What's next month?
Yeah, come give a talk, come sponsor.
What are you gonna talk about?
Django ORM, is that it?
Yeah, you.
Yeah.
The Node web guy?
Node web guy, you're the Oscar, or, yeah, you're the
I'll take
Python
the
programming
Yeah,
guy.
I like
I
it.
like
I can do something.
Yeah,
Python.
especially if it's a deep dive, because we did Django, we talked a little bit about the ORM last year.
You see
Yeah, you did an
don't you?
overview.
Dive deeper.
I
Yeah,
remember that.
CGI,
yeah,
don't
if
you?
you want to dive deeper, that sounds awesome.
So that's something I tried, it was a huge failure.
CGI?
Blew up.
Failures
Those
are
are
good stories.
common
That's
gateway
good.
interfaces. You just get a,
I'm not the web guy.
but this is like really
I remember
basic.
Jeremy, do you have
I did
a-
one for stuff, I was like, whoa, I can do this.
But this is like basic, you have a file that outputs to STL, and the web browser just sends that to a web server. It's not efficient at all, because you're, yeah, like a Perl script or something like that. No, you're a web developer, you don't even know it. You don't even need to learn anything. You could be on an island with just your laptop and you can crank out a web plate. I know that you get desperate enough.
We should actually do that.
But I will not do web developers.
Cool, are you learning Django?
We do. Yeah, we do.
But I might
So we got a time with Watson. So internally, we're
this or Flask,
Yeah.
so.
I say internally. We play around with
I'm actually
things. We use Watson
Yeah.
for transcript
I have-
extraction. We
I have
play
Some
no
around
people
with
to
it.
actually do so.
But really, you know,
So- One of the nice things about working
Django is
with
super
is
easy.
not having
Documentation's great,
that's also
so
honestly,
something
that
that
takes
takes
like
like
video processing.
I'd have to relearn.
For what I need
you know?
It's not like part of the platform yet.
I'll look into
Use
it.
one.
Yeah, it's got a good
Yeah.
To do automatic.
See you next month?
Yep, I'll be here.
Like very basic
First
and
in front, and then
I come
you
here
can
to learn.
upload
So
yourself
I
in the
saw his
background
video, like
automatically.
I saw his star
That's not
lessons,
content
like
extraction.
3D lessons that you gave.
And what about the?
Freelance Django, stuff in it. I was asking all those questions.
Yeah,
Why? Because I know,
Yeah,
from the
now,
years,
like
some-
the, well, like what Apple's doing with Animoji, like unless you have a depth sensor.
Oh, cool.
I
Because there's not
actually
just like,
did,
you know,
money for
Photoshop,
developers
it's just an
because
image and it
it's
just like,
coming on.
you know.
Just the tracking.
Like, I
your
need someone for
tracking
4
points
months.
from your facial recognition,
So
yeah.
just
Like that's something
very
we
basic.
don't.
What?
Animoji like is amazing.
I mean, if anybody.
I'm gonna meet him on Tuesday.
Let's
Email
get
me
tracking.
and tell me people-
That's your music
now.
thank you studio. Enterprise
I told him to
custom.
come, but he
Yeah, still
said
be
that.
happy.
I'm gonna mention it because it's my second email back.
I don't know.
I did email.
If he didn't like doing them, and that like killed it, and they're not there anymore, but they still don't do it, like they got out of the habit.
Maybe.
Yeah.
That's one of the things, if you don't keep the habit of it,
Yeah.
If I get money, I'm talking to you, I know when.
you know,
I'm actually
like, you don't
a
think to
job,
do it,
like,
and the
fees like
president of the
this,
company
or-
doesn't expect you to do it anymore, and so they're like, well, why are you doing that?
I can walk you back. It's like,
Okay.
You kind of,
Yeah.
you have really
Let me
have to-
let me wrap everything up. We can talk a
you
little
didn't
bit.
help?
No, like
Hmm?
business.
You didn't help wrapping up?
You're not.
Really, it doesn't look like there's
Yeah,
not much
I mean,
to wrap
we've
up.
done-
Yeah.
Some stuff is, he was talking about like business coming on a half day thing. Yeah, I mean, some stuff happens. Yeah.
Oh yeah, take
Why
that.
hack
Take them. Take them. Take beer.
But Josh does a lot of like weekend hack days that he puts up on the public internet and then tells salespeople about and then they get sold.
Yeah,
And
what made you
then,
put
that
that?
sucks.
And then you're like, hey,
I don't do that quite as much.
I couldn't do that quite as much. I did like, if you go to our website, there's like this whole like player gallery. And
You wanna
some of
wait
those
one?
ones sort of like hack days.
Thursday.
We've got a couple on there.
Presentation.
Yeah, like I've got one that's like, that I did a couple years ago, it's supposed to be a Christmas card, but we call it a postcard player, and it's like that, you know that like greetings from Austin, like mural? It's like a picture of that, and then every letter is like an interactive thing, you click it, and then they watch it.
More than 4 days out.
I'm really
It's just
happy
like a-
with
it's just like a
calendar and
custom
email, and I don't ever want to have another job.
Hey, so I was curious
Yeah.
what type of
I-
applications you relate to.
I really feel like
Task use, like,
Outlook people.
So the two
I feel like
problems
they
we
like
ran
hanging out
into
with
were,
calendaring pretty much.
it
I love that.
does not expect your jobs to take more than
I
1
don't have
hour.
enough experience to.
I mean, I used it
can't
at
turn off
university when I worked
timeouts
there.
at all.
Here.
So like you
I
can
haven't
set the
used it.
timeout really long,
Yeah.
but somebody can always upload a video that's
Fourth
will
Thursday
take
is the
longer to
27th.
transcode than your timeout,
I
right?
have
And
quality.
the other, like the biggest headache
I think that was
was,
like near the
so
high
celery
end
is
was pretty.
optimized, and it's not actually celery at all, it's
Because like,
Actually, I submitted it for.
no, it's not the task program, it's something that was,
Oh, really?
the library that was between celery and the task program.
Okay.
But I'm still gonna try.
Well, yeah, and I mean, if it does work, that's great. Then you get experience. Yeah, that's awesome. How long do you think it is?
Well, so PyCon is going to be 25 minutes, so I'll probably try it. I'll probably go 10 minutes over.
Yeah.
It's my
So
I
the
might
thing
find
that, the
another
thing that
talk,
knows how to
just
like
if it's
make
gonna
a
be in that
task
half
work
hour-ish.
against, you know, RabbitMQ or Redis or whatever, that's a different library.
I would prefer to actually have
And
two
that
talks
library
every
has
night, or every month, so.
compiles like
Is
buildings.
Is it supposed to be a 2-hour thing?
That.
And so like 1 hour each basically?
Yeah, roughly, like with Q&A.
And
So he was
when
complaining
you
that he went
fetch
too long, and I was like, actually,
tasks
that's,
to do,
you got it.
it
Yeah.
doesn't fetch one task, it fetches
We're gonna get out of your hair in just a minute.
So,
Give me
and the
a
idea
second.
is to reduce network latency if your tasks only take like a second.
Thanks for
But
reminding
the
me.
problem though is that you can't turn it off.
Yeah.
You can reduce it down to 1, you can only prefetch 1 extra task, or if you set it to 0, you prefetch everything.
I was like, I recognize him.
So the problem we would have is somebody would upload like a giant video.
But also,
Giant, like,
I should have you were wearing a Bitbucket jacket. I should have.
giant video.
Thanks, man.
And
Yeah,
after
sure.
that, you do this
Let's
little
check and
video.
make sure that's
And then
actually
the
your
person
book.
uploads a tiny video, and
It
wait
should be.
for the 3-hour 1080p video for their like 30 seconds, 720p video.
The other guy, Harry,
And you
hasn't gotten back to me at all. So there you go. Yeah. All right.
So that was
Sweet.
like,
Hopefully,
and we looked for a long time.
Man,
to find somebody.
I thought about that up front. It would have been like, you can win prizes at High Texas come this year. But
This is like,
that's a pretty good prize. Yeah,
It was out by.
he got the Raspberry Pi.
oh, nice. I have one too, but
then we probably weren't looking
Oh
at
yeah,
something like what
that's
we
it was a door prize at High Texas back in November. It was that, but Amazon. It was funny. They shipped me the books. I got the Raspberry Pis. They shipped me the books, but they put them in an Amazon, I had them shipped to an Amazon locker because people steal them or whatever. FedEx said they delivered it, and then Amazon never sent me the code and said, sorry, it's taking too long. Like, I looked at the tracking number and FedEx was like, it's delivered, but, so it ended up.
You should make a complaint to Amazon.
I probably should have.
No, I'm serious.
Oh, really? I ended up, they refunded me the money. They took it back like 4 days later, after I hadn't come. Or no, they waited like a week. Well, I had to order it again. And then they were back ordered. So it's been like, I reordered them 3 months? Yeah, it's been 2 months. It's been 2 months. Yeah, yeah.
Backward like 6 months, man. He was supposed to come out in like October. And
yeah, it's still not out.
You just had to publish it. You just had to publish it.
Well, I don't know, like, what's the deal? Like, publishers, like, did he finish printing it in time?
We've been, like, in my team, we've been looking at it.
It's the third edition with all the optionals.
Yeah, Java 8 stuff, right?
It just came out. He just finally said
it. It did finally ship? Okay.
A long time.
I don't think that this was backordered as much as just like out of inventory. Because like I ordered it the 27th or something. I emailed you and the other guy, like it was like, yeah. No, so I reordered it like the 27th of November and they were like, no, we don't have it. And then I reordered it again in December. I was like, no, seriously.
The new Raspberry Pis are awesome. Wi-Fi, built-in Bluetooth.